Hello, hello. Can you guys hear
Hi.
me okay?
Hi.
Yep.
Yeah.
Hi. Hi.
Cool, cool. Let me share my screen and we can get started in like 5 minutes. How's it going?
Yeah, good. Thank you. You?
Oh, yeah, I'm doing good. Right when I finish the class, I have to drive like 5 hours to my daughter's college.
5
Yeah.
hours. That's crazy. Eh?
Well, this is what's crazy. If you're not from the United States, I'm gonna drive 5 hours north, and I'm still gonna be in my same state.
Yeah. So it's huge.
It's gonna
It's
be
huge.
like another maybe 3-4 hours to leave the state.
Damn.
Where I live, you literally can drive around the entire country in 15 minutes.
Oh wow,
Where
where
are you
is that?
Gibraltar,
Ah,
in South
Oh
Spain, literally 15 minutes round the
wow,
world.
so you literally know everyone in your country.
Literally, there's 35,000 people.
Wow, that's
Yeah.
cool.
We
Yeah,
prefer it, right? I chose to live here. I've traveled the world. It's very quaint, good weather, access to Spain. We all bilingual here, pretty much.
yeah.
It's great.
Well, I have a lot of friends in Spain, and when I tell them that I'm gonna be driving 5 hours and not leaving my state, they look at me like, "Holy shit! Like 5 hours here, you're definitely in France now." So it's or
5 hours, 5 hours from say Valencia. You're in France.
oh yeah, for sure.
5
Probably
hours from
from
here.
Madrid. Like if you drive north 5 hours from Madrid, I think you leave Spain.
100%. You probably be in Bilbao. 100%. 3
Yeah.
hours, 3-4 hours. Yeah.
I'm from Germany. If you somewhere in the decent middle of Germany, you can be in 5 hours in any of 7 different countries.
Yeah. It's crazy.
Europe is very compact.
In my state, I'm leaving, which is nuts. Completely and absolutely nuts. Yeah, the United States is so freaking big. It's hard to comprehend. Like here from Florida, it takes me to go to Madrid. It takes me about 7 hours and a half, plane ride. So it takes me to go to California 6. 7 hours and a half, completely new continent.
Yes.
Europe. But if I go to California, it's 6 hours plane ride. Just crazy. Almost the same time.
Yeah. I live in Virginia, so from Virginia to Florida, it's going to be about, 16, 18 hours?
Yeah.
Driving. Yeah, driving, yeah.
Well, Americans love it, right? Americans love driving for some reason. You just love it.
They have no other choice than loving it.
The Amtrak,
that's what happens. Like
the Amtrak, the train system here is not as developed as Europe. The Amtrak is kind of horrible. If you used to TGV in France and then probably you come down here, you're gonna say, "Whoa, what's that? 19th century?"
Yeah, that's a surprise. Yeah. You're right there. I mean, in Europe, Spain, the AVE can get you anywhere really quickly. High-speed train. And
you should have high-speed trains connecting all your major cities because of the distances.
Yeah, they were having this project for
that's
years.
Not the American way.
No, the auto industry, big money.
Third world countries, bro.
Absolutely.
This is not by choice, by the way. I'm pretty sure people here will love high-speed trains going everywhere, but we have a very strong lobby where they're not gonna let that happen. Like we have a train now in Florida, which is a high-speed train, the Bright Line, and it goes from Miami all the way to Orlando. So that would be approximately 4 hours and a half driving time. Now you can do that a little bit faster. You don't have to drive. It's very convenient and nice. And it's taking like years and years to get that project approved. And it's just lobbying. Like the big car does not want that to happen, obviously. They would prefer to have you just tied to your car. So yeah, unfortunately, that's the way it goes. Other than that, and besides the point of trains and whatnot, this is a very big country, and everything is very far away. As soon as you go outside the main cities, like, I have to drive to get my groceries, and it's like a 20-minute drive, right? So everything is like that, right? If I want to just drink coffee, again, it's going to be another 20 minutes driving. It's just crazy how far distances are.
Yep.
And here in Florida, it's not that bad. I have friends that live in Los Angeles, and a good commute time, like, oh, I'm fine. I don't work as far as you do. It's like an hour. So commuting one way, 1 hour, which is just nuts.
Yeah, I mean, when I first graduated and got a job in London City, I was like, this cannot happen. I refused to commute. So I'm like, where can I live in the world? So I moved to New York, worked in Wall Street, and then Gibraltar was a bit of it's got advantages on tax, and all the hedge funds were here. So I'm like, I have to move to somewhere where I literally can walk to work within 10 minutes.
Yeah, for sure.
I refuse to spend my life.
It's kind of over time, I've learned to appreciate both ways of living. They're very different. The European way and the American way. There are pros and cons to both of them. Absolutely. I don't think one is better. It really depends on who you are, what you like, and at what stage in your life you are. Like if you're a young person, I usually recommend to people, if you're a young person, ambitious, you want to make a ton of money, there's only one place in the world you should go. Yeah. If you are in your 40s or 50s, you already make your wealth, and you want like a quiet life and just live life, there is only one place to go, and that is not the United States. So, it's pros and cons. Everything has good things.
You're absolutely right.
I do find the balance in the UAE though, right? I mean, I spent a lot of time in Abu Dhabi, and the UAE has the balance of both. It has access to, making lots of money, and the driving, 2-hour drive, you can get to, different parts of the UAE. So it's got the in between. Obviously, it depends how you want to live your life. But yeah, that's the closest I've seen, like a hybrid where you have the safety. One, for me, that's the most important thing for me is the safety. So where we live is extremely safe, almost zero crime. And because I'm raising kids, when you're young, it's different, right? Single, and you can take on the risk a little bit and live in cooler places, I guess.
Okay, so let's get started. All right, so session 2, for those of you who did not attend yesterday's office hours, there were a lot of conversations where we tried to fix the setup for everyone. Like, I think we did it like 4 or 5 times. So if you're having problems running the code, just check out the office hours yesterday. The link should be up there and ready for you to download. Okay, so what I'm going to be covering today is how we can go from that discovery phase and how can we start just creating things, right? Remember, session 1 was about discovery, all of the things that you need to do at the beginning of the project, how to build a POC, the questions to ask, etc. Now we want to get a little bit more serious and get it just moving, get the project on its way, right? So what are the main things that you have to do to get the project on its way? And I want to start by talking, I think somebody asked this during session 1, but I want to start by talking about model-centric and data-centric AI, because these are the 2 main ways to build machine learning and AI applications today, especially machine learning applications when you're dealing with models. There is the model-centric AI, and there is the data-centric AI. And I think both of them are necessary. So model-centric is when you take your data set and you don't do anything with it, right? You hold it, fix it. Yeah, I mean, you hold that data set fixed. You don't mess with it, and then you focused 100% on your model. Okay. So here are some of the updates that you will do during model centric. Like you can tune hyperparameters of your model, you can implement ensemble models just to try to extract a little bit more out of your data. You can use custom loss functions, you can do transfer learning, regularization techniques. All of those things are considered model centric updates. Okay. And the process, you have it here on the right column, which is you start with a fixed data set and you pre-process it. You establish a baseline model and use that as a performance benchmark. And we're going to talk about baseline in just a second. And then you iteratively improve your model. Okay, step by step, you try to make your model better. Most books out there will focus on model centric. Every time you buy a book and you read it or watch a tutorial, they will focus on model centric. They want you to, let me just turn on the camera a little bit. They teach you how to improve the model to get everything that you want out of the data. Now, on the other hand, we have data-centric AI. And data-centric is based on how can we hold the model fixed? Like, we don't want to mess with the model. We are going to try to produce a good data set. Okay, the best possible data set. We're going to manipulate the data so we can get better predictions. Okay, so the process is similar, obviously. Here, you are going to train a baseline model and use it as the benchmark, same thing that we did on the model-centric AI. But in this particular case, we're going to use that model to identify issues with the data set and try to improve them. And here you have some specific updates that are considered data-centric updates, like doing feature engineering. When you're creating new features, you are not messing up with the model, you're messing up with the data, you're modifying the data. When you try to improve your labels, you identify any mistakes in the ground truth and you try to improve those. When you try to balance the data set because it's unbalanced, when you do data augmentation, synthetic data generation. So all of those are data-centric updates, right? Now, real success, in my opinion, comes from using both, okay? I usually tell people that being a machine learning engineer, or this is a common saying, not that I'm the only one saying it, it's like 90% about the data, right? You've heard that before. And that is very true because there is a lot that you can do on your data to improve it, to make it better. Not just about making better models, but also about making better data. Kevin, go ahead.
Maybe you're going to get to this, but can you talk about for data centric, like when you're updating if you're not updating your model, but you're updating your data, how does that change sort of the output of what you would get? Or where does that updated data sort of fit in to things?
I can give you one simple example. So imagine that I have a data set and I train a model, and my model is 80% accurate on that data set, okay? I already have the model, so I go to the data set and I'm going to review all of the labels that we created, the ground truth. I have a team that's creating those labels, and I'm going to review those labels, and I find that 5% of those labels are incorrect, okay? So I'm going to fix those labels, and I run it again through my model, and now I get an extra 2-3% of accuracy. So that is just a simple example on how modifying that data set alone without touching the model can get me better results. Another example would be same data set. Remember that last session we talked about some feature engineering techniques, like for example, binning, where we identify some data that we might want to provide to the model and create a separate feature in our data set with those values. So for example, the time component, when we have a date, but we know, because we know the business that we're working on, we know the use case, we know that holidays are very important. So we create a new column that basically specifies whether a specific date was a holiday or not. So 1 or 0. And we train the same model, we train with that new data set that contains the new column. And that will give an additional clue to that model, or may give an additional clue to that model to get even better results. So those are examples how modifying the data alone will get you better results. Does that make sense?
And do you still update the model or still like retrain the model on that?
You would, yeah, you would
Okay.
retrain the model with the new data. Yeah, of course. Yes.
Gotcha.
Ahmed.
Hi, Santiago. I have a question regarding the variance inflation factor. Do we have
Sorry.
the multicollinearity?
Okay.
Do we have to apply it also, or it's necessary, or it's just like it depends on the model?
It really depends on the model. Yeah. It's going to depend on what model you're using.
Okay.
Vitor.
Hey, what's up? So
What's
the
up?
question is mostly regarding, I know that we're talking mostly about classic machine learning, which involves structured data, but
Mhm.
how would you classify LLMs training that it's mostly unstructured data? Which
Okay.
one?
So by the way, classic machine learning does not involve only structured data. In fact, all of the classic machine learning that I've done, it's only
Oh,
on
yeah.
us,
Sorry.
because you have
Sorry.
images, audio, and you have text.
Correct. Yeah.
Yeah.
My bad, because I specifically work mostly with structured data. But yeah, you're correct.
Yeah, so the same thing applies here. So I can give you one example. In my case, one of the projects that we were working on, the main problem was with labeling. And the reason labeling was a problem, it's not because people were incompetent and they were producing bad labels. It's because it was really hard to agree on which label was the right one. So let me give you just an example. Imagine that we are doing quality assurance for cans of drinks, okay? So you get a can, we take a picture, and we want our model to say if the can is good or faulty, like it's broken or something, right? Like we don't want that can. Imagine that problem. Now, some of the cans, when they're coming out of the factory, they might have like a small dent, okay? We do not want to sell to the customer cans that have dents. But how big is that dent is we have to define that. So somebody, one labeler, might see a can with a very, very tiny dent in it and might flag that as a bad can. Another labeler uses a different criteria of the size of the dent in order to flag it. So if that person sees a very small dent, he might not flag that can as being problematic. So that what you get when you have, like, imagine thousands of images going through hundreds of labelers, what you get is conflicting information for the model. You get your labels, you might think everything is right, but the model is getting different signals, mixed signals. Sometimes dents should be flat, sometimes dents should not be flat. So how do you fix that? Well, you need to have a proper process and documentation of how big a dent must be in order to be flat. Now, this sounds obvious in retrospect, but when you're starting a project, you don't have those guidelines because you haven't thought this through completely. You have to go through the process, realize what's going on, go back, document, relabel, and move forward. All of that documentation and relabeling and all of that which belongs or is under the umbrella of labeling, better labeling, belongs to data-centric AI. And the amount of time that you have to spend there is just humongous, right? Remember, I said during session one, I don't know if you caught this or if you remember, that most engineers see labeling like something beneath them, like, hey, I get paid too much money to be looking at images. And that is a very, very, very stupid frame of mind. Anytime I see a person like hinting that they are, too up there to be spending their time labeling, I know their work sucks for sure. Because you cannot model something good, you cannot come up with a good solution if you don't spend a lot of time looking at your data, being images or audio or text or whatever it is. Does that make sense?
Yeah. Yeah, 100%. Having that said, in which one, data-centric or model-centric, will you classify LLMs?
Well, the LLM is the model, so it really depends on what you're doing. If you're improving the LLM, if you're fine-tuning an LLM,
You can have both approaches for building LLMs. You're saying.
yeah, you can have both. Like, let's say you're working with one LLM, you're working with Llama 4 in your problem. You might be number one, you might focus on your data, and that would be data-centric. Number two, you might be fine-tuning Llama 4 just in order to make it better for your problem. That would be model-centric. Does that make sense?
Yeah, it does. Thank you.
Vishwanath.
Hi. So in data-centric techniques, yesterday we did talk about tracking and everything. So in data-centric, let's say if the data is huge, so how do we keep track of these versions? I mean, like the space is, we'll soon run out of space, I assume, if the data is too large.
What do you mean? How do you version the data set? Is that what you mean?
Yeah. For example, in computer visions, especially in computer vision techniques, if we do data augmentation a lot, right?
Right.
Especially if some of the classes are really low and all of that. So if you were to test and keep track of all the metrics that were there, then I'm assuming in data-centric approaches, we do keep track of data set versions and all of it, on which data set.
So you can, yes. So there are multiple ways of doing this. So number one, there are ways to version the data set. There is the simple way, which is every time you modify the data set, you create a new folder with a new date. There are the sort of like official ways, DBC, and there are tools to do to keep versions of data set. I've always used, and I've always been lucky enough that using just a simple way of versioning data sets have been enough for me. Like, for example, just, hey, we're going to make a big modification to the data, just create a new folder with all of that data, duplicate it, that's it. That's good enough. But you don't have to do it like that. You can just do DBC or something like that. For data augmentation specifically, there are multiple ways of doing data augmentation. Number one is permanent data augmentation, where you actually create physical files that you save, and those are augmented versions of your images. The second way is doing data augmentation on the fly. So while you're training, you create data augmentations, like you augment your data set, but that's just, it just goes away. Those images are never saved. They're shown to the model, but they're never saved. The next time you train, you will recreate those augmentations. In those cases, you don't need version. Make sense?
Yeah.
So the second thing is, if you have algorithmic steps in pre-processing, you mean, which will always create the same kind of augmentation.
So when you're training using any deep learning library, you will have the ability to generate augmentations on the fly. As part of the process of feeding into the model, you create those augmentations.
So you model then you version then the process rather than the data set.
That is correct. In those cases, you will be versioning the process. The data set is just going to be the same. It's going to be fixed. But any time you go into the train the model, you generate those augmentations.
Mm-hmm.
Yeah.
Hi. Should I
Hi.
go? So maybe you will come this, I'm not sure, but my question is, let's assume we are beginning of the project or like the product. How we will be assessed, or when or how we will identify which approach we will come through, like we will approach to the problem or the project.
You mean
How we will be, which tool we will be used, like data-centric tools or model AI approach?
Or you mean for what? For any problem? That's
Like
what
any
I'm like.
project.
What's that?
Any project, you have data, and then you approximately what you will be predict or will be come out. So
Yeah.
which one we will be used, data-centric AI or model-centric AI?
Both. The reason I mentioned the importance of data-centric is because a lot of people forget about data-centric AI and they focus 100% on the model. So whenever they try something, they build a model, it's not good enough, they keep hammering, trying to identify a new model that's better for them, okay? And
Okay.
they forget that they should be looking at the data as well. So you should be using both of them. There are tools, different tools to do both. But yeah, you should always keep in mind that modifying your model is very, very important.
Now, that was confused me because in the project we use both. I thought like we should be more, how say, being on one of them is more. So that was the confused me. Okay, thank you.
All right, so I'm gonna keep moving. If you have any other questions, just please leave them in the QA. I'm going to go back. Mark, I hear you, but I have to answer the questions or they won't make sense at the end of the session. I know you want me to keep the case moving. I'm gonna try to do that, but I really need to take some questions. All right, so going forward, before you start iterating on anything, and I don't know if you noticed this as part of the process that I show you for model-centric and data-centric, one thing that you should do is establish a baseline before anything else, okay? So it's very common for me to meet a team now that I just do consulting most of the time. And they ask me, hey, can you come and see what we're doing and how we can improve? And usually my first question when they're building a model is, what is your baseline? And so some teams look at me like I'm speaking Chinese. They do not understand me. I mean, there's nothing wrong with Chinese, which I just don't understand it. So they look at me like, what do you mean by baseline? Like, you're trying to beat what? Like, how do you know your model is good? So if I ask you guys, is a model with 90% accuracy good or not? The right answer is, I don't know. It depends, right? Like if with a random process, I can achieve 90%, then obviously a model is not good enough if it's 90%. If I ask you to select a person at an airport, you go to an airport and I ask you, select a person that is not a terrorist. Any bozo, any one of us would be able to do that with 99.99999% accuracy. Because literally most people are not terrorists. So if your model is only 99% accurate, your model is a piece of shit. That's just the way it is. That's why a baseline is so important. So this should be your first goal, creating a baseline, okay? And sometimes the way we create a baseline when we don't have something to go off of is just creating a very simple, straightforward baseline. And then you try to outperform that simple baseline. So let me give you a couple of examples of what a simple baseline would look like, okay? So number one, we have a random baseline. You don't have anything else to go off. So first establish, if I use a random pick, how accurate am I going to be? Again, with the terrorist example, if you randomly pick a person, you will be like 99.9999% accurate. Meaning you randomly pick a person not to be a terrorist. So that would be a random baseline. The second algorithm that you could also use is what's called the zero rule algorithm, which we always predict the majority, the most frequent class. So maybe most of you have seen the Titanic problem. Basically, this is a famous data set. It's a very simple data set for people who are learning machine learning. And in this data set, your goal is to determine, given the information of a passenger, whether that person survived the Titanic disaster or not. That's the goal, okay? So two algorithms here, or the two baselines that you have here is the random baseline. If you apply the random baseline to this problem here, which, by the way, this is the data of the problem. I have it here on the screen. 32% of people survived, 68% of people died in the Titanic. The distribution of women and men and children is what you see there. But picking it by random, you can be 56% accurate just by random, saying whether a person survived or died, just by random, which means that anything under 56%, if you build a decision tree and your decision tree is 53%, your model is worse than random. Your model is just crap. If you use the zero rule algorithm, meaning anytime you give me the passenger data, I'm going to say, well, that person died. Just that's the zero rule. Anytime you tell me, I'm going to say it died. Just by doing that, you are going to be 68% of the time correct. So your model better be above 68% accuracy for it to have predictive power. Does that make sense so far? Now, these are the ways you start if you don't have anything to go off from. But sometimes when you're building something for a company, you can have a stronger baseline. For example, how good are humans doing this task? Like if a human were to solve this problem, how good are they? Which, parentheses, usually not 100% depending on the tasks, right? Humans made a lot of mistakes. But that would be a good baseline to compare against the model. I think I told you about the pricing model, and I mentioned that the pricing model that we built was not better than humans. It was still useful because it reduced the amount of work that humans had to do, but humans were better at making money, at selling stuff and making money than the algorithm that we built. That algorithm, of course, I left, probably got improved, but when I left, we could not beat human performance. So that was a baseline that we were using. How good are humans doing this? Another baseline that we were using is how good are existing systems doing this. I think I also mentioned that we were comparing our model to an existing system. And we were able to beat that existing system. That was our baseline. Make sense so far? Any questions so far? No? Good. Let me see the questions here. Okay, so how is fine-tuning LLM model-centric? We are updating model weights based on our data or for a specific task that they call data-centric. Well, when you're fine-tuning, you're not just, what you're thinking about fine-tuning is very different to what I'm thinking about fine-tuning, okay? So the way you're thinking about fine-tuning is taking a model that was trained before and you're retraining some of it. But that is not, so fine-tuning has become an overloaded term. When we got into LLMs, they started calling fine-tuning something a little bit different. So here is where fine-tuning, the root of the word, that's not a thing, but the original way of thinking about fine-tuning. You take a model and you do specific things on the layers of your model, like you freeze some of the layers, you change things like the learning rate, so you can pass it to another data through it. Maybe you change the output layer, you retrain it on new data, but you are modifying the way you trained it, okay? That's what you're doing. So with the same parameters on a new data set. That's not what you're doing. What you're doing is retraining with certain or with different parameters. Like one example is the learning rate of your model has to be set very, very small. So the changes during that training process do not completely screw what the model already knows. You want to adjust the knowledge of the model. You do not want to reset the knowledge of the model. Now let's look into an LLM. When you are fine-tuning GPT-4o, whatever, I don't know if you can fine-tune GPT-4o. I think you can using OpenAI's API. With a data set of 100 samples, if you were to open that model and just do fine-tuning like a regular training, you will completely reset GPT-4o. You will erase the memory and you will only teach GPT-4o the 100 samples of your data set. That is definitely not what you want. So what happens behind the scenes is that they're gonna freeze most layers of that model, okay? So most of the layers are just gonna be frozen. You're not gonna touch them, okay? But certain layers will be left open. By open, I mean those are the layers with values that you will modify. But then you're gonna modify them just slightly, meaning you're not gonna use like a large learning rate that a value before was 1 and now by passing 100 samples, now that value will become 17, not a big jump. You're just modifying them with a very small learning rate. So you're just readjusting that. That's why this is model-centric and not data-centric. Hopefully that makes sense. How is this freezing of model layers implemented? It's just a flag. If you wanted to understand how that happens behind the scenes, for every layer, you have a Boolean value that says whether it's frozen or not. And when that Boolean value is false, like a training pass, is not gonna modify anything there. You're just gonna leave every number the same. That's it. That's how that is implemented.
So the propagation algorithms just say, oh, this weight will not be modified by propagation.
That is correct. So when you're training, when you think about a neural network, the way we understand how neural networks work, the top layers, the layers near the input, are going to learn general concepts. So imagine that we're talking about images here, okay? So the top layers will learn things like shapes and colors and forms, so abstract concepts about images. The more you move toward the bottom of the neural network, towards the output layer, the more specific knowledge is going to be learned. So for example, if you're training a neural network on images of cars and trucks and planes, the closer you get to the bottom, you will have neurons with the knowledge of what a wheel looks like, or the specific, lights or the windshield. I'm just making stuff up. So more specific things that belong to a car. So when you want to fine-tune that model to now learn about bicycles, you do not want to mess up with the general knowledge, right? So bicycles also have shapes and shadows and colors and forms, and the general knowledge stays. What you want to fine-tune is the knowledge that's more specific, because now you're going from cars to bicycles. So you need to fine-tune the layers near the output. Those you will leave open, unfrozen.
I see.
The rest will be frozen. Okay, so is changing final layers for ResNet or Inception also constitute fine-tuning? Yes, so what you do is you usually change the final layer. That's also part of the fine-tuning process. So you have a model, and let's say that model outputs 100 type of cars, 100 categories for cars. And now you want to do for trucks, and there are only 50. So you will replace that final layer. That final layer you will throw away because you don't need it anymore. You don't have 100 cars. And you connect a brand new layer for 50 trucks, and you fine tune that model. So that last layer knows how to classify trucks. That's what you would do. Yes. Okay. Stuart, what's up?
Hi. Yeah. So I think I know the answer to this, but for testing versus the baseline, like in your example, when you were trying to predict which products are going to sell, do you test that by looking at history? So you have one history period that might be 6 months ago and another history period that was 6 months after that, and like he is today. So do you test the 6 months versus the 6 months, that because you don't know what the future is going to be yet?
That is correct. So that's usually the way you would do it. In our case, it's a little bit more complex because we had to do simulations. So basically, we need to say, the problem is that if I put a product at $1,000 and it doesn't sell for 30 days, I don't know if that project would have sold before if I would have put it in 900 or 800, because it didn't happen. So I didn't do that. So we had to run simulations using historical data. Now, what you're talking about, we're going to talk a ton about that. Part on this session, part on the next session, especially, which is evaluation, which is back testing. So using back data to test the future, we're going to cover that in detail, I promise. So we're going to get there.
Great. Yeah, that's what I thought it would be, but just wanted to check. Great.
Alex, what's up?
Hello. Yeah, just a question about Titanic data set. As you mentioned, it's pretty straightforward, simple data set, and you probably can solve it by using just conditional probabilities, like, given that the person is dead, what was the probability that it's a man or a child? So my question is, how do you decide? Is there like a rule of thumb where you're like, okay, for this problem I need to solve ML, or for this problem I can rely on something more simpler?
Yeah, I usually try to, so number one, my knowledge is finite. So I'm going to try to start with whatever I know it's going to be the simplest way to solve that problem. Some people smarter than me will start with even a simpler way. Like, I will not try to solve this with statistics for only one reason. I'm not great at it. But that is my fault. That's not to say that with statistics alone, you shouldn't be able to solve this. I will throw machine learning at this because that's what I know, and that's the simplest way I try to do it. Now, within machine learning, I would definitely start with a decision tree, never with a neural network, just too big, too complex. A decision tree should be good enough to produce good results on a Titanic data set. So again, that's my process. What is the simplest thing that I think will solve this problem? Let's start there. That's what I would do.
Thank you.
Cool. Serhii.
Yes, Serhii. My question is, how do we know which model would be good enough after we already created baseline, we're iterating over and over again? And for example, the client himself don't know what is a definition of good enough model? How do we know where to stop?
Yeah, so good enough depends on your business. So I really have to ask you what your business needs. So good enough means, for example, in our case, it did not mean let's build something that's better than the department of people that we have. Good enough for us was, let's build something that helps that department of people stay the same size. So we already have 100 employees. We don't want to hire more employees. We have to augment those employees with technology. Let's build a model that gets us there. That's good enough for our department. Now, that will look very different if you want to create a robot that operates on people, does surgery on people, right? Good enough in that case means mortality rate has to be lower than a human surgeon. That would be good enough there. So that's how you measure good enough.
Much lower, because I had an assignment during my studies for that topic, and no one accepts something technically where you cannot blame a person for if it's not very, very, very much better than a human.
Yeah, definitely. Leon, what's up?
if you have a team of people that you're starting a project out with, would you divide the members of the team through different strategies? Like one person would do neural networks, person would do, a random forest or decision trees, another person would do anomaly detection? Or would you have the whole team like focus on one area first to kind of try to decide whether this is this is feasible or not, or, get the data enough to know, what to do later in the future?
I guess it will depend on what we want to accomplish. If it's sort of like branching like that would make sense to get us quickly to a solution that's going to work, I would probably do that. I don't see why not, but it really depends. It really depends also, like, for example, we might know right from the get-go that a decision tree would be good enough. And sure, there might be a neural network that's better, but we don't care at this point. What we care about is just to put the system out there. So I would rather focus on having that end-to-end system working with a decision tree, and later on we can focus on optimizing for a better model. Now, if what we really care about is that we don't know what model is going to work, then maybe using people like that would be a good idea. But I think it will really depend on the problem. Cool. All right. So we have a baseline. The next thing that we usually recommend to people is, I'm going to go to you, Mark, in just a second. The next thing that I usually recommend to people is we want to create an initial evaluation protocol. Now, we're going to talk a lot about evaluation in session 3, but at the beginning, while I'm just starting to explore and creating these models and whatnot, we need something as quickly as possible, something that is simple enough, and later on, we're going to make that evaluation protocol a little bit stronger. But this is important because it's what tells you whether you're making progress or not. If you don't have an evaluation protocol, you do not know what's going on, okay? So the first thing is you need to identify the metric that you are going to be looking at. And that metric, hopefully, is connected to your business somehow. So if I tell you this, going back to the pricing model, because it's an interesting metric. If I ask you, for the pricing model, we were looking at accuracy, you will say, what does that even mean? The model is accurate, telling us for how much money to sell a product. What does that even mean? If I tell you that we were looking at root mean square error, because it was a model that it was a regression model. Like, imagine me telling the CEO of the company, oh, we were able to decrease the root mean square error of this model. She would have been like, what? What? Like, nobody cares. So the metric is, are we making more money or not? Are we making more profit or not? That is the metric that's related for the business. And it's your job to connect your technical metrics to the metrics the business cares about, because that's what matters. Nothing else matters. Okay? It's always about money. That's it. Now, there are multiple ways to building these thingies. Multiple ways of building this evaluation protocol. I'm just going to try to go through a few examples here, including, when you're training a model from scratch and when you're just using generative models like an LLM, like what you should do. Okay, so when you're building your model from scratch, the simplest one metric that you should use, not metric, but evaluation protocol that you should use is, obviously, you need to train your data and evaluate it on data that you have not seen, right? You train your data, you train your model using some of the data, and you evaluate your model on data that you have not seen. Looks something like this. And for most of you who at least have started looking into machine learning, you've seen this before, 100%. This is the entire data set. You're gonna get a portion of it and train your model on that portion. That's what the training data will be. Then you take the remaining portion of your data set, and you can use some of it to validate your model and some of it to test your model. Can anyone tell me why I'm making a distinction here between validation and testing? Vishwanath, go ahead.
Yeah, so we use validation usually for hyperparameter testing.
Okay.
Like there are different folds of validation data. Sometimes it's k folds or cross validation. So each validation data might give us different results. So also to tune the parameters and everything, we use this. And then finally, when we have decided which set of parameters gives us the best result, then we do it on test data.
Yeah.
So essentially, we are not supposed to look at what do you call uh, the answers in test data at all, but in validation data, there is some flexibility to that, I believe.
Okay. Anyone wants to add something different?
Yes. So validation data is used to evaluate the model, how well the model has been trained, and maybe work on improving the model if it has not been trained well or it has not reached the desirable goal. And you would not involve the test data until you're satisfied with that model.
That is correct. So the idea is you train your model on the trained data, and then you decide, okay, I need to improve it. So I mean, let's just evaluate it. You use the validation data, you evaluate the model, you see the model is, let's say, 80% accurate. And you're gonna look at what can I make better? And maybe I'm gonna modify the labels, I'm gonna modify the hyperparameters, I'm gonna retrain my model, reevaluate my model, check again, iterate. Every time you're iterating, you're using that validation data to see how you're doing, whether your changes are taking you in the correct direction. Okay? And then you're done. So now my question is, another question for you guys is, let's say I do those iterations until my model is 97% accurate on that validation data. The validation data is telling me, okay, you went all the way from 80 to 97% accuracy. Why do I even need the test data? I already did all of the iterations. Question for you guys. Mark, go ahead.
Yeah. The thing is, we introduce a bias with the training set into the model. We introduce with the training validation a bias by our process also into the result. The test data, I have a follow-up question after that. The test data ensures that something not only our model have never seen, but our process has never seen at data, makes sure that we are not run into some structural bias by our methods.
Yeah. So as we try to improve our model by looking, like the validation data is going to give us feedback. We are going to take that feedback and modify the model so it gets a better result on that validation data. And I don't know if you're catching what's happening here. I'm going to use that feedback again to improve the model so it gets better at that validation data. So I'm actually biasing my model so it improves on the validation data. The validation data is not the real world, it's the validation data. So the more I run this process, the closer I'm going to get to that validation data, to get good results at that validation data. But that does not mean this model is going to be good in the real world. That's why we have the test data, which has never been used, has never been looked at. And I want, after I finish the process, I need to use that test data to check whether the model is actually good. It might be great at validation, it might be bad at test data. My professor used to say, use the test data only once and then throw it away. And I thought, you are a stickler, you're stupid, you don't know what you're talking about. You might be a professor, but I'm better than you. I will never do that. How stupid of you. And then I learned over time how right was my professor. Okay. So when you're building a production system, your test data should always change. And we're going to talk more about that in session 3. where I teach you how you rotate the test data constantly, you keep it fresh, but that's the goal. You never try to use the test data more than once, okay? Mark,
Mirosensky, very close though. Is this, when you're saying that, you're trying to make the validation data, you're using the validation to improve your training and test, obviously you reserve for the real world. Is this something along the concept? I've heard a concept called overfitting. Is that something related?
That is correct. So overfitting means fitting to a model means adjusting. You're adjusting the model to a data set. So when you are overfitting to the data, you're over adjusting your model to the data set, right? You're looking at those specific samples too closely. You're very good at those. You're not good at, generally speaking, solving for the world. So overfitting is a bad thing. If you don't have that test data, you do not have a way to check for whether your model is overfitted, because you run that with the validation data only. You're biasing your model towards the validation data. It's going to look great when you look at the validation data, 100% accurate. When you put it out there, it's just 80% accurate. They're like, what just happened? Well, you overfit to that validation data. That's what you did. Okay. Dinesh.
Yeah, hi. So when you say like the training data 60%, so I'm building something like a classifier. So it's good at predicting at like one category, but it's bad at the other category. So do we need to consider those set of like 60%, 20%, 20% in each category, or how do you define the categories?
Okay, so I think what you're talking about is, we call it stratified sampling. So I don't know if this is, so hear me out. What stratified means is, maybe you have a data set with 3 classes, and those 3 classes have different numbers. So one class is, you can see one class in 50% of the data, and the other 2 classes each in 25% of the data. When you grab 60% of the data, if you are unlucky, you might be getting within that 60% or 50% of one class. So there is nothing that's going to test that class. And then the other one is just slow, it's represented barely in that data set. So what you do is to stratify sampling. What that means is that 60% of the data is going to have the same percentage of the classes.
Okay. Yeah.
So any library that does splitting will support stratification. So you can say, I want to stratify sampling based on this category. And it will set 60% with a proper representation for all classes. That's what you want to do.
And what is that library? I'm new to this. So
for example, if you use scikit-learn, scikit-learn will let you do splitting. You can split, and you can use stratification. You can do stratified splitting. By the way, the 60%, 20, and 20, those are just guidelines. Depending on how much data you have, you might do 75, 10, and 5, or whatever it is. Okay, so those are just guidelines.
Cool.
All right, let me open the queue here. Mark, go ahead.
I'm wondering, but I've read it now in the internet also. Obviously I have memorized it wrong. I wonder why the validation set is the validation set and the test set is the test set, and not vice versa. Because I'm thinking about software development. You have your software, you test it, you develop it, you test it, and at some point you validate it before deployment.
Yeah, so if this helps, some people call it the development set. So they call it the training set, the development set, because developers, the ones that are building the model, they will use it, and then the test set, because it's the final one. So it's just naming. I like to call it validation. I think
it's also exactly like you described it. It's all over the net. But by being a software process guy, where we have to work with the V models a lot, not the software development model, but the process model, the process design model. Validation is always a step to make sure that you have produced the right thing for the customer and not that you have done a good job on your development part. But okay, it is what it is. It's
okay. So before I go to Shabana,
thank you.
let me tackle. Okay, I know this is a conversation that DJK and Leon are having in the chat. You guys help me. Let me know if you need me to chime in. Shabana, go ahead.
Yeah. Hi. So based on this, I understood like we are having a 60% of teaching data and 20% validation and 20% test. And in the teaching data, like I have 60%. So I actually created the 60% data based on the real world scenario, and I will do some labeling based on the real world examples. So how it actually differ from test data?
How would that actually differ from test data? Is that the question?
Yeah, because while I'm creating a 60% of data, when I do label and those kind of process, I will actually compare with the real world data, and then I will label those 60% data to train the model. So in this case, how it actually differ from test data?
Okay, so you do not create 60% of the data. You have data. You have to label it all. So all of your data needs to have labels, and then you split that data. So let's say I have 1,000 samples, and using the 60-20-20, I'm gonna get those 1,000 samples, and I'm gonna get 600 of them to train my data set, my model, and I'm gonna have 200 of them to validate my model and improve it, and then 200 of them for final testing. But you start with the whole data set, okay? And the whole data set has to be labeled. Make sense?
Yeah.
Inti, go ahead.
Yeah, no, it's critical that the test data is represented well. And either we have it's very bad to have a very little amount of test data to test, and it's also very bad to have unrepresented data to do the testing, because if we just have only one flavor of a data and not all the variety of flavors that we want to test it with, then the test is really not going to be of high value.
Yeah. 100%. Enrique.
Yeah, hi. I'm not sure if I understood this part correctly, but say that I'm training my model and doing the validation part, and I get to a point where I'm confident with the model. I pass to the final test, and then the performance drops dramatically. In that case, what's recommended?
So in that case, it's recommended you go back and you continue iterating on the training data and validation data. If I'm assuming you do not have more data, let's assume that there is no more data to be had. So my recommendation is, you saw the performance dropped to a point where it's not good. Do not look into it. So do not do anything like that. Just go back and realize that some of the changes that you performed are just getting you closer to the validation data. So you're going to have to rethink something. Sometimes you might need to give something away, meaning, well, right now I'm at 90% in validation data. I need to make adjustments that might get me to 80% later on, but those are adjustments I know that are not going to be biasing my model. So you have to keep iterating and then test again. Ideally, however, you do that test, you realize it's 80%, you're going to get that test data and you're going to throw it away. By throwing it away, I mean you can add it to your training data set, for example, and grab a fresh set of data to test your model later on. You're going to keep improving your model and redo the process. But every time you touch that test data, ideally, you're not retouching it again. You're not reusing it again. Because the same thing will happen if you iterate with that test data, same thing will happen. Yes, you are going to improve the model of that test data, but when you go to production data, it's not going to do great. Make sense?
Yeah.
So that's the point where understanding what might be biasing your model is important. Because if you do not understand the things that you're doing to bias your model, it's just really hard to, it's you're looking at a number and you want that number to improve, which is the accuracy of your model. And you can make that number improve if you wanted to, but if you understand what you're doing right now is just biasing your model, you will understand that will be a bad improvement. If you do not understand what things you're doing that are biasing the model, it's going to be hard to improve that model, because see what I'm saying?
Yeah.
It gets really, really complicated. Okay, so I'm going to get one more question, so I move on. One more. And DJK, you were the one with your hand up. Please, anyone else have questions, just type them in the Q&A so I can keep moving.
Yeah, thanks, Santiago. So I have a quick, more conceptual question about model lifecycle in the context of project contractual delivery. Say you sign up to deliver a model, so you go through this process: training data, validation data, test data. So you hand over to the customer, you walk away, right? So is this basically the model, or how do you conduct user acceptance testing, right? So because it seems like you keep iterating, you keep iterating forever, right? So at some point you reach your exhaust your budget or time or whatever. So what's the best practice? What did you encounter?
By understanding what good enough it looks like. If you do not understand what good enough is, you might think that good enough means 100%, which is unachievable. Okay, the 100% does not exist. You need to understand what good enough is and go based on that. So our first version might be, we want a model that's capable of solving 1 out of 3 samples. And the other 2 we're going to pass to humans, whatever that is. So that is what you're aiming at. And whenever you have a version does that, you pass it over to the other team, which will integrate with the whole process, or you will start working on the other process. But understanding what's good enough is key, so you know exactly where you're going. That's why you need to have a baseline. That's why you need to have a good enough criteria. Make sense?
So it sounds like the final stage of a project, you basically use test data to validate, to get the last snapshot of baseline, and then you basically close the project and move on. Or,
right.
You have example of whatever.
The test data will give you that final metric. Let's say we're calling it accuracy here just to make the thing simple. But let's say your goal is to have 80% accuracy. As soon as you get a test data, when you test your model, it's above 80%. And if that's good enough, you need to integrate that. Assuming that you have a big team, somebody else will integrate that model, and maybe you're going to work on the next version of the model to improve it. So that's sort of like the way. Cool. All right. So one problem with the holdout structure here. It's very simple, but it might be misleading. Why do I say it's misleading? Who can tell me why you might get misleading results from this? Jean.
It's only a small part of the data, so it could be a bad part of the data.
That is correct, right? So you're testing with just a portion of the data. So, you might be unlucky, and that portion of the data might be too simple. So therefore, your model is scoring very high just because the test was very simple. Or the opposite is also true. The test might be very hard. So you're iterating on something when your model is already good enough, but you don't know that because the test was really hard. It's also a very inefficient way of taking advantage of your data set, especially when you don't have a ton of data, because you're reserving a lot of the data just for validation and testing purposes. So your model is not learning as much as it could because it's not seeing all of the data. You're reserving some of it. So another approach for this initial evaluation protocol is cross-validation. Very, very popular, okay? It's more expensive to run. You're gonna see why in just a second, but it's way less biased than just a simple holdout set, okay? So the way cross-validation will work is something like this. You will get your entire data set and you will split it in multiple folds, and then train and validate with each one, with each of those folds separately, or each of those iterations separately. So let's say the first iteration, we are reserving the blue fold, this portion of the data, that 20%. That's on the first iteration. That's the data that we're going to use to test the model on. But first, we're going to train it on all the 4 green slots. So 80% of the data, we train the model, and then we test it on the blue fold. And then we repeat. And we now notice how we're selecting a different 20% to test the model. And then we repeat with a different 20%, and so on and so forth. This will be a 5-fold cross-validation. You could do 10-fold cross-validation, 20-fold cross-validation, etc. Right? Usually, you will never go above 10. Actually, regular applications will never go above 5. That should be overkill. But this is how you train and test your model. And then, at the end of this process, you take and do a final evaluation. When you finish all of this process, you're going to average the score, the evaluation score of each one of these iterations. So you will get the 5 accuracy values, because you get 5, 1 per each. You will add them up and average them, or divide by 5, and that will be your final score. Does that make sense? Do you guys see why this is better or less biased, I should say? Vishwana.
Yeah, so the earlier method that you mentioned for normalization and standardization and all of that, so we should split the data first and then do the transformations?
You should split the data first. Yes, you always split first, then you transform. You never transform before splitting the data. And we can talk more if you add something to the Q&A at the end of the class. I can go an hour why that is bad. Transforming before split. Okay.
Okay. I'm assuming it's because the mean kind of changes if the validation set is also used.
Right. Jejan.
When you said accuracy just a minute ago, you essentially meant precision, right?
Precision is a different metric. It could be the metric that you're looking at, but precision, recall, and accuracy, those 3 are different metrics. So accuracy, if you think about it, accuracy is out of 10 samples, how many of them do I get right? What percentage of them do I get right? Right? So 100% accuracy will be out of 10 samples, I got right all 10 of them. That would be accuracy. Precision is a little bit different. Precision is anytime I try to select one individual category, how many times that is the one that is correct, the one that I selected. So if out of 10 samples, I decide that the positive samples are number 1, number 7, and number 9, well, I will evaluate the precision based on those 3 samples, how many of them were correct. Now, recall is another one, which is different. So recall will be out of 10 samples, I want to select all positive samples. Let's say I get number 1, number 7, and number 9. I will evaluate recall based on the total ones of positive samples. Not the ones that I selected, but how many of them, based on how many existed, how many of them I selected. Those are 3 different metrics that are usually used in classification problems. They are somewhat related, but they're very different. Hopefully that makes it clear.
Makes sense. Thanks.
Vitor.
Hey, I'm used to do cross-validation with scikit-learn library, which is a very manual process on a Jupyter Notebook. Is there a more modern framework, library, or approach to do cross-validation and learn a more automated way to do it?
It's just, there's no more modern way. It's just, that's the way it is. There's nothing to modernize about this process. It's just the way, right? It's scikit-learn is perfectly fine. You're good there. Mark Mereshinsky. Jesus Christ, I need to learn that.
It's okay. Anyway, just for clarity on the diagram, when we have the 5 iterations, it's not that you split the data into 5. It's the same data that was split, and then just like you picked a different one for your test case, and you're just training it 5 times, essentially.
I do not understand why would that be different. Sorry.
Oh, I guess it would be kind of like in the original case, you reserved a section as validation data. And this one, your validation data kind of becomes a different subset of your like of your 80. Like you have your 80%, and 20% of it is validation, you know, or whatever. 1/5 of it is your validation of your sample, and that 1/5 is a different 1/5 for each iteration. But as far as the data, it's not like you have 5 times more data. It's like, no, it's the same data.
Okay, I see. Yeah. So you have the same data. You're just switching the portion of the data you're going to use to test your model.
Excellent.
That's it.
Thank you. That's it. That's all I wanted to know.
Yeah. Kevin.
Can you just, I guess, give a quick example of the transform data part? Is that like labeling, or what would that be?
The transform will be, it's what you do with, remember the data set, when you get it raw, it might have categories, text categories. Remember that we want to vectorize those. Or you get the age and the salary example from session 1, where you need to standardize those values. That's what you will do during the transformation process. You will make the raw data in a shape that's good enough to train a model, right? So standardization, handling missing values, vectorization, all of that will be the transform data step. Make sense?
Okay, and that, yeah, I guess in that way, you'd want to do that after sort of splitting it up into different iterations, because you want, I guess, the output might be different given that.
So yes, if you transform first and then you split, you are overfitting. And again, I don't want to get into this because my face gets red. That's one of the most common mistakes that people make. They first transform the whole data and then they split it after the data is in good shape. It sort of like makes sense to do it that way, right? Like why would you want to just split and then do transformations? That's kind of stupid. No, it's not. So that's the way you should do it, or you will be overfitting. I promise I'm going to tackle this in the Q&A after we finish with the session, because it's such an important topic. I just don't want to hold the session over that. But yes, split first, then do transformations. Mate.
Yeah, hi. So let's say you're trying to find the best hyperparameters to improve the model performance. So you're doing maybe grid search or Bayesian. So in this case, doing a cross-validation can, I don't know if it's exponential, but it can really, increase the number of iterations you have to do, and computationally, like it could be very expensive to do. So how do you tackle that?
So what you can do, if you have like a big data set and you still want to use cross-validation to, let's say, find a good model, you don't use the whole data set. So one thing that you could do is just get a portion of the whole big data set, and on that portion of the data, you do the hyperparameter tuning, and you find the best hyperparameters, and you hope that the portion of the data that you selected is good enough, is representative of the bulk of the data. That's the only approach that you have if you wanted to use cross-validation. The other approach is that when you have a ton of data, cross-validation loses its benefits, okay? So the biased part that cross-validation is trying to solve, it's less prominent when you have a ton of data, because it's very hard to get unlucky with a ton of data. So what that means is that cross-validation is not that advantageous in those cases, so you don't use it. Hopefully that makes sense.
Yeah, okay.
Iman.
Hi, Santiago. I think this is a kind of a follow-up question. So on the transformation step and then doing the split, so sorry, the other way around. So I think my question is, how about if we lose a lot of relevant or important records during that step? So when you kind of do the split, then if we do it beforehand, and then we're going to lose a lot of records because of the transformation. Let's say we have null values and different types of errors. Then the kind of the weights of your splits, they might not be quite good enough.
So
I understand the overfitting problem, but this potentially depends on your data set, could be a huge problem.
So I hear you. That is a risk that you run, but you want to run into that risk. Let me tackle that at the end. It's just a big rabbit hole. The problem is that it doesn't matter. What you're worried about is that when I do the split, a specific example will go to the test data set. Therefore, I'm not going to train my model on that sample. Therefore, when my model goes to production, it's going to see one example like that and it's going to fail. That's what you're worried about. That it's just, I'm not going to say dumb worry because you're not dumb, okay? Just want to make clear. That is a worry that you should not be worried about that because that's going to happen anyway. Because guess what? In production, there is data that is not part of your data. It's not part of your data set. So either way, you have to prepare your models to see data that is not part of your data set. And again, I'm going to give you a few examples at the end. But what you cannot do is transform first because now you're biasing your model. Your model is going to be too good to be true. Your model is going to have information because you're transforming before splitting. And I'm going to give you specific examples if you want to at the end of the class. So you don't want to do that. So hold with me a little bit longer, and I'm going to get into that. Even if you have to jump out of the session, you can watch the recording, go to the Q&A, and you will see that. Okay?
Thank you so much.
Well, I have two more. I'm going to answer these two more, and then I'm going to keep moving on. Terry.
Sorry. Yeah, my question is about like exact proportions, exact percentage. I heard like they usually say when you have big data, like really a huge amount, like millions of items, you actually don't need like 20% for tests. Probably 1% or 5% is enough. But is there some mappings or rule of thumb of I mean, mapping from dataset size to that proportions?
No. You know exactly the rule that I know. The more data you have, the less data you have to reserve for testing. Because
so there's no such thing like if I have 100,000, then 10%, no?
No, and you have to use your head. Like, for example, it's not based on only numbers. So maybe you have 1 million samples. But those million samples, each of those are very different from one another. So even though you have a large data set, you still want a big enough test data set so it's representative. But maybe you have 1 million samples and the data between one sample and the other is very similar. So now you only need 1% because that 1% is going to be representative of the whole population. So there is no rule of thumb. It's only understanding. Yeah. Dylan, what's up?
Yeah, so I'm working with some time series data, and I guess I'm just wondering, is there some sort of randomization that needs to occur or does it happen in just the tokenization process where it's just going to be not going to matter?
So you don't want to do this for time series data at all. Okay, so this is not going to be good for time series data, obviously, because here you're testing with data that you're not supposed to, the time component in time series data is critical. So what you want to do for time series data is usually backtesting, which I'm going to talk about in session 3. I do backtesting even when it's not time series data. I love it, and that's the way I keep my test data fresh, but definitely not cross-validation, if that's what you want.
I figured there's probably some, separate, something thing. This isn't just like image processing and things like that. Yeah. Okay.
Right. Yeah. All right. So one thing when you do cross-validation, one thing that to keep in mind, I'm gonna just brush over this really quick, is remember when you're validating your data, you're generating here 5 models, right? So for each one of these splits, you're gonna be creating a model and testing that model. Okay. So there are 2 ways that people like to deploy these. I prefer one of them, but there are 2 ways that people usually deploy these models. The first way of deploying this model is by you getting option 1, train a new model using the entire data set. So when you're done with validation, you're going to go and take all of your data, all of it, no splitting. You're going to take all of the data, retrain your model with all of the data and deploy that model, okay? Notice that you're not evaluating that model anymore. You already did during cross-validation. You're just retraining a new model and deploying that model, okay? And the second way of doing this, another option, is you take the 5 models that you generated and you ensemble them. So basically, you literally deploy 5 models, and whenever you get an input, you put it through all 5 models, get the final answer, average the final answer, and that's the answer that you keep. 2 ways of deploying cross-validated models. In the code walkthroughs, you will see that I'm using option number 1. If you have questions about option number 1, leave them in the Q&A, and I'll get to you at the end. Okay? Now, those are sort of like the two high-level recommendations when you're starting out training a model. Very high level. We'll see more of them in session 3. If you are doing a generative model, if you're using an LLM, your evaluation is going to have to be different. Okay? So a good process, high level, if you're using an LLM, looks like this to train, to test whatever the heck you're doing. Okay? So number 1, design a prompt set to test your LLM application. Okay? So for example, you can use an LLM to generate realistic user queries. That will be a way to design a prompt set. Design a prompt set that will test your application. Number 2, define the rubric. Like, how are you going to score those answers? My recommendation always is to keep this simple and use binary values or binary rubric, okay? Meaning passed, didn't pass. Something very, very simple so you can actually do the evaluation. I've seen teams creating rubrics where the scores are like 5 different categories. It's just hard to evaluate like that. Try to keep it simple. What is acceptable? What is not acceptable? Okay? Now you're going to run the model. Make sure you randomize the prompt order while keeping the system prompt and temperature constant. So you're going to get all of your prompts, randomize them, run them through the model, and then you're going to track things like cost and speed. Then you're going to score each answer of your model. Okay? When you score your answers, make sure you audit some of them. If you're scoring automatically, make sure you're auditing some of them so there are no hallucinations there, or at least you know that there are no hallucinations. And at the end, you're going to aggregate all of those scores. Sophisticated way of doing it will be including the time, the cost and the speed as part of that score. And that's the way you come up with that final metric of how good your system is. Again, this is very high level. This is something to get you started. The proper way to evaluate LLM-based applications is called error analysis. That's the best way. I'm going to get blue in the face in session 3 talking about error analysis. This is something just to get you started. Okay, I need something quick. How do I evaluate my LLM-based application? Do something like this. Iman, go ahead. I'm going to answer 3 questions. Iman? Mark, while Iman figures out what's going on. What's up? You're muted. Yeah, you're still muted.
I have 2 ways to mute, and they are not showing up. Okay. What does in this context mean rubric? Is that like a class?
So the rubric will be, how are you going to evaluate those prompts? So like, what does that mean? Like, how are you going to score these things? That's
So
what I mean.
fail or
I recommend people to do a binary
okay
rubric, but you might not want it.
It might
binary
be bad, average, and good also.
That is
would be-
correct.
Okay, understood. And what is the temperature
Remember-
constant?
Wait, remember that you might be evaluating over multiple categories as well, not just
Okay.
every prompt is good or bad. But you might have
good, bad in different categories.
categories. Yeah, you can.
Okay.
You might. Yeah.
Okay. And what is the temperature constant? Have
The
we here
temperature is to pass
in
the model.
Eiling?
Well, when you're using a model, you have the ability to pass different temperature values. If you want a model to be a little bit more creative, a little bit more deterministic.
Okay, so that's
Yes.
that's a hyperparameter.
For the model, yes.
Yeah. Okay. Got that. Thank you.
Leon?
When you're running your model over your prompt set, are you clearing context over each sample in your prompt set? Or are you using the same context window for the whole set?
Yeah, that is a good question. I want to say it depends, but usually what you want to do is try to reproduce whatever your application is doing. Like if your prompt set, it's part of a single conversation, that's what you want to test, then no, you don't want to clear the context, because in production, you're going to be using the same context for all of the different prompts. If this is simulating like prompts coming from different users, then yeah, you want to just start from scratch. So every query you should not have memory involved. Is that what you mean? You should be from scratch. Yeah. Try to reproduce whatever you do. Okay, Jean?
Okay, I noticed that when under define rubric, you say favor binary decisions, which kind of suggests you're looking for only a single true, false, good, bad answer. But then under score each answer, you say each facet of your rubric, suggesting there might be multiple binary criteria.
Right. What I mean by that, and I should have been more clear, you might have different categories. Like, for example, I want to understand if my answers are consistent, yes or no. If they are comprehensive, yes or no. So those two are two different facets. Consistency in the answer with respect to whatever, and comprehensive. Those are two different facets, and I'm evaluating each of them as yes or no, instead of 1, 2, 3, 4, 5. Does that make sense?
Cool. Thank you.
Now, ideally, you have one question and you're evaluating one metric, but that's usually not the way it works. Different applications might try to do different evaluations. Point being, keep it as simple as possible. Again, you're starting out here, and what you want to do is you just keep it simple. You'll see in session 3 how we can make the evaluation even better. Peter, I'm going to keep moving on. If you don't mind, just add your question there so I can keep moving. It's 11:27, and we are not even at half point. All right, so keep in mind, do not make changes that you cannot measure. Very important. Okay? Do not make any changes that you have no way to understand whether they are improving or getting back to you. Very simple to remember. I hope that stays with you. All right, so this section here, I'm going to try to move fast through this section so we can get to the RAC session quicker. That I know a lot of people want to see that session. So when you're picking a model, I'm going to try to recommend you a few ideas to pick the best model. Either if you're training a model or if you're just using an LLM out of the box, you will have the slides. So yeah, it should be good enough. So number 1 rule, use the simplest solution that could possibly work. In this case, the simplest model that could possibly work. Simple models are easier to use, faster to iterate on, obviously easier to maintain as well, and they're often all you need. So one example is I was working with Spot. That's just a video that I recorded. If you haven't seen it, it's probably on YouTube somewhere. We were teaching Spot how to respond to commands, so we could talk to it, because just getting data from emission was just a pain in the nuts. And we started with just a simple, if person says walk back, move 3 steps back. If person says walk forward, move 3 steps forward, right? That's the way we started building this functionality in Spot. Unfortunately, we, meaning the company, our company who built this, knew the proper commands. So we said walk back, and Spot moved back. As soon as we deployed this and gave it to customers started saying things like, get away from me, or back, or shush. And we did not hard-coded all of those. We started hard-coding them and then realized this is getting out of hand. We have to replace all of these by a simple model. What is a simple model? Just using a GPT model. I don't remember. I think it was 3.5 at the time when we built this. Simple model. Take the command, and translate that command into the actual action that we need to do. That's what using a simple model looks like. Okay, so you are going to use foundation models when their capabilities are good enough to solve the problem. I think somebody asked me, when do you use foundation model or your own model? I think yesterday. Why not? This is your slide. You will build from scratch when you need control efficiency or specialization. Okay, foundation models are great for many, many applications, but they are generalists. If you need more control, if you need more specialization, you need to build from scratch. By building from scratch here, I'm also including here like fine-tuning, like your own model, like creating either your own model or fine-tuning an existing element. Okay, so the vast majority of specialized models leverage pre-trained models. So you start from something. You do not start from scratch, like literally from zero. Okay, so that's what fine-tuning does. You start somewhere, and then you can fine-tune that model. You can specialize that model into something that's a little bit better without having to spend a ton of money retraining that model from scratch. Okay, something to keep in mind before I show you the criteria that you should sort of like write down somewhere is that you need to understand the trade-offs between using a foundation model or building your completely new model. Okay, there are trade-offs, big trade-offs. Using a foundation model is going to be way cheaper, way faster, way easier, but it's probably going to give you less, I'm going to call it accuracy here, worse results. Fine-tuning a model is way more expensive. It's going to take way more time. It's way more difficult. You have to maintain it, but it's probably going to give you better results. You have to consider those two. Okay, so some of the things to keep in mind when you're trying to pick the best foundation model are here. Just going over them really, really quick. How good are they to follow instructions? What is the size of their context window? These are, in general, the criteria that you might want to think through, the questions that you might want to think through, deciding, do you want to go with Llama 4 or GPT-4 or Gemini 2.5 Flash or Gemini 2.5 Pro? These are some of the most important criteria that you might want to look into. Okay, keep this slide, maybe print it out, and the next time your company asks you, you're going to ask these questions. If you want to go with your model, if you want to build from scratch, these are the things, very different things that you want to consider. Okay, what are the data requirements for my model? Like, what happens when I have a ton of data? Is my model going to be too slow if I have a ton of data? Or where am I deploying this model? Am I going to be deploying this model on a robot, on the edge, or am I going to be deploying this model in the cloud? And I don't care about costs or anything. So these are criteria for that. Final warning. Be very careful with state-of-the-art models or self-called state-of-the-art models. Because unfortunately, the academia is incentivized for producing papers. Okay? And that incentive is very, very different than the incentive in the industry. If you're an engineer, don't pay a ton of attention to state-of-the-art. Everyone can claim state-of-the-art. They basically create a data set, a benchmark, where they are state-of-the-art in that benchmark. That does not necessarily translate to real-life performance. You have seen these with LLMs. You've seen Llama 4 claiming the best at math, and then you ask 2 + 2 and it tells you 17. It's just a piece of shit model. It was fine-tuned to beat a benchmark. So very careful with this, Okay, don't fall for that. All right, any questions about that? Just add them in the Q&A. Model versioning and tracing, again, very quickly through this, and then we get into, I'm gonna tell you that this is important. That's all that you need to do with this. Model tracing and versioning. Whenever you're either building models or using models, you want to keep as much information as possible. You want to track it, okay? You need to keep the versions of your models when you're building them. That's what MLflow is for. We talked about this a lot yesterday during office hours. MLflow will help you keep or do model versioning. That's the only way you have to go back to a previous version when something goes wrong. You also need to take care of tracing. And by tracing, what I mean is it's just getting the raw materials that you need to do to reproduce a problem. Okay, to understand why something is not working. Okay, this is your insurance policy. Very common to go to a team, they have none like this implemented. Very common, professional teams. They don't have anything like this. So if they need to go back, they have no way going back. They don't know what they did yesterday. It's not just about the code. It's not just about having GitHub, okay? When your model is in production, you need to have traces. You need to have logs, okay? So this is what a version is for a model. A version for the model is just snapshot of the weights, the code that produced that model, the data set that produced that model, the configuration you used to produce that model. That is what a model version is. That is what you're gonna get with MLflow. That is what you are going to see that I'm doing in the code walkthrough. I'm doing model versioning in the code walkthrough. It looks something like this, right? So my entire pipeline does what you see there. And there is a register model step. And that register model is the one that's going to log the parameters that I used to build that model, the configuration that I used to build that model, any metadata necessary that goes with the model, the metrics, like how accurate that model was on my training data, on my validation data, the artifacts, meaning any files, any like literally physical files that I need together with the model, and the lineage of the model, like where is it coming from? What experiment produced this model? How do you trace that model all the way back to the data set? All of that information you need to keep. That's why you use things like MLflow. Okay? Now a trace is a little bit different. This is detailed record of a model's execution. So traces come when you deploy that model. Now that model is in production, you're using models, and you want to trace, you want to just log stuff. And as much information as you can, please do it, log it, okay? So for example, let's say you're using your LLM, and this is the same application that we saw during the first session. You want to make sure you're generating traces that contain things like the input data that went into the model. You want to save that. This is the input data that the user sent me. This was the prompt that I used. Okay? This is the model version that I was using. These are the parameters that I used with that model. These are the tools that the model had access to in order to solve this input query. This is the final output that the model provided. You want to log all of that. Okay? Leon, do you have a question?
I do. Can't advocate enough for experiment tracking and MLflow and everything you're talking about. It needs to happen on any project. That's my experience. What is your experience using something like MLflow for LLMs? I have not actually done that yet.
I have not used it for LLMs. I should look into it. I have not used it yet for LLMs, just to track for LLMs. Yeah.
All right. Thanks for that.
So final slide of this mini section, and then we get into RAG. You cannot, like, there is no such thing as production-ready applications without proper tracing and proper versioning. Okay? No such thing. You really need to do this. So again, if you're doing consulting or you're part of a team right now that's trying to build an application using this AI, ML, tomorrow, tomorrow, Friday, you go raise your hand and tell your project manager, we should include these things. We should start doing tracing. We should start doing model version. That's the way you improve that. Okay? All right, so let's get into the final section of today's session. That's RAC, or in context learning. Okay? So the whole idea here is, and probably most of you know this already, is the foundation models, unfortunately, they hallucinate. They do not know what they don't know most of the time. So if you ask, yesterday I was trying to build a shortcut in my phone. I was trying to build a shortcut using ChatGPT. I wanted the shortcut to email me every morning the latest result of the Dodgers game. I'm a Dodgers fan, MLB baseball. And I open the application every morning to see how was last night's game, because they play very late at night for me. But I wanted just for the fun of it to just get an email saying the Dodgers won, the Dodgers lost, whatever. And GPT was not able to provide that because it needed access to the internet, and for shortcuts, it doesn't have access to the internet. So it kept hallucinating the answer. It kept saying they lost to the Pirates. No, they haven't played the Pirates in a long time, right? So it just kept hallucinating the answer. You solve that, or one way to improve that is by adding context, giving the model context. Meaning you don't let the model come up with the answer. You sort of like constrain the model into, look, your answer is going to be here. Okay? Some people call this grounding the model. You give the model additional context so they generate answers from that context. Okay? So think about something like this. This is the same application that we started. But now instead of sending a query directly to the model, we're going to add one step. In the middle of sending the query to the model, we add one step, and we're going to call that step context construction. Basically, we're going to get the query from the user. Okay? We're going to get that query, and we're going to create that context. We're going to retrieve data from documents or databases or from whatever that data is. We're going to use that to add to the context. We can also maybe use external tools, like maybe a web browser, to find information on the web, just to construct that context. And then we're going to give the model the original query plus the context that we found. That's the idea. That's what we want to build. Okay? Does that make sense so far? Any questions so far? You do not understand why this is necessary, so you're going to ask me why this is necessary. Anyone? No? Okay. Cool. It sounds like, oh, okay, there we go. Dejan, go ahead.
Hey, maybe quick question on how do you, like, what's the best way to design these RAG systems? Like, how do you think of what should you place in this vector database so that you can send the user's query to the vector database and enrich the context? So, like, can you explain a bit, just like, how can we, you will get there, all right.
I'll get there. So, all right, so here is where RAG comes in, okay? So this is, hopefully you guys understand why we need that context, why we need to add, like in my case, for the Dodgers game, it would be great if I had like a blurb of text, or I will search on the internet, give me the last 7 games from the Dodgers, the results, or something like that on the internet, and I will give all of that information to the model, and the model will extract the proper answer from that information. That's the motivation of this. That's why we need something like this, right? That's the idea. Or if you're building a chat for your company, and the customer asks, is there a return policy? Okay. The model doesn't know. You need to give the model maybe documentation, your knowledge based, or maybe the content of your website. You will give the model, hey, this is the entire website. Look throughout that website and find the return policy, okay? And answer the question. That's the motivation, okay? That's what RAG comes in. The whole idea with RAG is augmenting the generation with real-time search. That's the idea. You are going to do real-time search to grab the context that you need and ground the model responses. Give it to the model. That's the whole idea with RAG. So here is an example of a RAG application, okay? Very high level. Let's say the query is, are there any requirements to fly to Spain? That's the user asking a model. The model does not know, because the model was, the last time the model was trained was in 2021 or 2023. So if there is anything that happened after that, the model doesn't know. So what we're gonna do is have the context construction step, go and grab from maybe the government database or like a website. We're gonna retrieve the visa requirements for European countries. Just please give me all of the visa requirements from European countries. We're gonna grab that information at this step. And we're gonna provide to the model, number one, the query, which is right here. Are there any requirements to fly to Spain? And number two, all of the visa requirements for European countries. And we're gonna let the model answer or construct an answer based on all of that information. That's the example. Mark, what's up?
But that means at some point in time, I had to have trained the model to, in principle, understand how to extract visa requirements from any kind of information. So old information that looks like that. I'm not really understanding what's under the hood of LLMs at this point in time. But when I think about it, I would assume that the additional meta information or updated information we give the RAG, we give the context, we give to the model must be trained in similar context already, right?
So the model, so this is not explaining how an LLM was trained to be able to do this task. We need to part from the assumption that the model knows how to, given a context, how to extract relevant information from that context. So based on that, if we start from, if that's our ground level, and you trust that the model was trained to do that, and it's outside the scope, obviously, of RAG, how the model was trained to do that, based on that, our job is to provide that context. And
so we assume that the model is able to understand the context because it might be trained with similar types of context, maybe outdated or stuff like that.
Foundation models are very good at doing this. So they're very good at extracting relevant information from text, from documents. So if you give it from the context, you give it, hey, these are all of the visa requirements from specific for all European countries. Get me if there are any requirements to go to Spain. The foundation model will be very good at doing that. So if you trust that, your job as an engineer building an application, okay, is to provide the context to that model. So how do I get and how do I inject all of the visa requirements for European countries to this query? That's your job. Make sense?
Kinda, yeah.
Sari.
Can we somehow bypass the limits of the model context? So if the amount of information we need to digest is like really huge.
Yeah, that's gonna happen. And we're gonna see how you can sort of like work around that in just a second. But yeah, that could happen. Imagine that I have the entire government database. And anytime the user asks for something, I'm going to grab the entire government database and give it. That might be more information that fits in the context of the model Therefore, in that case, you need to understand what portion of that database to provide to the model. That's where the next step comes
So
in.
we not necessarily need to retrain the entire model, right?
You don't have to retrain it. You just have to select the proper context for the model. The context window is just a limited space that you can give the model. The model can only read so many characters, okay? So let's say your context window is just, for example, is 1,000 characters, okay? Whatever you tell the model has to be under 1,000 characters, okay? That's just the way it works. And right now, modern models have like huge context windows. We measure context windows in tokens. Think of a token approximately like a word. It's not a word, approximately like a word. So let's say 1 million words. That's a 1 million context window. That's a very big one. So whatever you give the model has to be shorter than 1 million words. So how do you select 1 million words that matter? That's the goal. Okay. All right, Caleb, what's up?
Okay, so if you don't provide it the updated visa requirements and you just ask it about the requirements, we know that it'll give us an answer, maybe old requirements, maybe made up requirements. Where does that come from? Does that come from the weights that are in it, or does it come from the context that's in it, or where?
It's coming from the knowledge that you trained into that model. So it's from previous knowledge. So at the time of training, the model would have learned those visa requirements, would have seen them before in the training data, because the company who trained the model scraped the whole internet, and the model learned those. And now the model is gonna regurgitate those visa requirements, and they're old or outdated or whatever.
So all of those are, everything we ask it about, every topic has been baked into the weights, the billions of parameters.
That is correct.
Wow,
yes.
Okay. Thank you.
But they're really, really big. It's hard for us to understand how big these things are.
Yeah.
They are really, really big, number one. And number two, they are great at compressing a ton of information. So the internet is big, but these models are capable of compressing it down to a few, and by a few, I mean billions of parameters, right? They're very good at that. And they're very good at recalling that information later on, so they can easily get it back on and reconstruct it, right? So when you ask about visa requirements, the model is very good at recalling that. It's like it's going to a database and finding that data and returning that information and regurgitating it back to you. But yeah, it's all baked into the weights. Yes, sir.
Okay, thank you.
Anuradha, maybe?
Yeah, I know. So it's a very specific question, actually. If I use an MCP server of some library with my LLM, is that like providing a context? Because I use Polars.
Yeah. So MCP servers, and we're going to talk more about MCP servers in 7.6, is a way to give model access to tools. That's basically what you're doing. You're giving model access to tools. There's more than that. MCP also support resources and a bunch of other things. But you can think about tools in two different ways. So read-only tools where you want to retrieve information. And that's why I had it like here. See how I had external tools here? And you can use an MCP server to access a tool that will retrieve context. Like maybe you go to the government API and retrieve the data that you need through a tool. So in those cases, the tool will be context construction. Tools can also be to act in the world. So when we talk about agents, you will see how you can use a server to do something, make something happen. In those cases, you're not constructing the context, you're just acting on the world. Make sense?
So it can be used both ways. Yeah. Okay. Thank you.
That is correct. Liam.
Sorry, difficulties. So with the foundation model, you can pretty much have a conversation with it about anything pretty much on the open internet, because that's what it was trained on. And so you're giving it very specific documents, text, pictures, PowerPoint presentations, so it to be more specific to your use case. Is there then a way to make it where you cannot have any other conversations other than what you have provided it to converse
Right.
about?
You can try through prompting. Remember, it's not an exact science. So through the prompt, you can tell it you're going to die if you answer with something that is not part of the context. I will hate you forever. I will pay you. People try all sort of tricks. LLMs, the better they are, the better they become at following instructions. So for the most part, they're relatively safe that they're going to stick with the information in the context, but they are not deterministic, meaning you might still get hallucinations and answers that are not sticking to the context. But for the most part, they've gotten to a point where they're pretty good at following that instruction and not trying to, come up with an answer that is not part of that. Here is where I've seen personally that they do not behave correctly. You're giving them context, but they also have different knowledge. What do I mean by that? Let's say you are asking about a specific topic, about math, okay? The LLM knows about theorems and stuff like that, okay? They already have a lot of that knowledge. And you give it a book as the context, and you ask about the Pythagoras. The LLM knows about that theorem, but you're also giving it a book that frames the theorem in a very specific way. Sometimes it's hard for the LLM just to stick to what the book says, and the LLM might sneak in some of the knowledge that it already has. Does that make sense? Because the model knows a lot about Pythagoras, it doesn't necessarily stick to the definition you gave it, but it uses that definition maybe, but it adds more to it, or it doesn't frame it the same way because it knows a lot about it. So you gotta be careful in those particular cases how this is going to work, okay? Sometimes you try the LLM to say things that are contrarian to its training, and the LLM is not gonna follow your instructions, right? So those are type of use cases that you need to be very careful, because RAG is gonna help, but not necessarily is going to prevent the LLM from going just off script.
So if
other than prompting, hold on. Other than prompting, is there a way to give more weight to the RAG vector database source information, or have they figured that out yet?
You're gonna have to fine tune. Other than prompting, those are your two levers.
Okay.
You either prompt your way into better answers, or you fine tune, try to align the LLM to the way you try to do things. Okay.
So if I would like to have an LMN analyzing my C code as a reviewer, given the company standards, I should be careful not to have an LLM that has been trained on general good coding styles, but only on the but only gives the current one as an either as a context, and only train it with the language standard or something like that.
Right. So what's going to happen with styling, specifically with styling, you're always going to be better off fine tuning. So it's not enough. Context is usually not enough to get the LLM to behave certain ways. Okay. Let's say I want an LLM to write like me. Giving the LLM examples of my writing as part of the context, usually not good enough for the LLM to do that. I've tried. You have to fine tune your LLM with many, 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 many samples of your writing if you really want good results. Again, RAG is not good to change behavior. RAG is good to provide information that the LLM should use in order to answer something, okay? Like, hey, what is my 30-day policy here? Or what are the visa requirements? Or, information about your business, about your products. That type of thing, RAG works. Changing behavior, not good. RAG is not going to be good for that. Hopefully that makes sense.
Okay, thank you.
Emla Wally.
I think you just answered my question. So mainly, I just need confirmation. So the whole RAG application is more like the developer should focus more on context, and then a little bit of fine tuning of the LLM model, foundation model, right? I think you already explained a little bit in your previous answers. My main concern. So my takeaway is more like focus on context, and then a little bit of fine tuning.
Your job when you're doing RAG, your job is how do I give the LLM the information the LLM needs to do its job? So it's all about context. How can I select the best information for the LLM? You guys are gonna learn something really quick, which is giving the LLM, like people say RAG is dead because now LLMs, the context window is humongous. So like 1 million tokens, you can fit the whole Harry Potter series in 1 million tokens.
Yeah.
So, yeah. Why not just give the LLM the whole Harry Potter series and ask a question? Well, because LLMs are not good enough. Like the larger the context that you provide is, the less I'm trying to find the word. The LLM is not going to be good enough at finding information.
Accuracy.
More versus when the context is too big. It's just like us. If I give you a book and I ask you a specific question, you are going to provide a worse answer than if I give you 2 pages and I ask you a specific question. It's easier to find the proper answer within 2 pages than within a book. Same thing happens with LLM. So the larger the context window that you provide, the less accurate the LLM is going to be in the answers. So even though these models are now accepting humongous context windows, they're still worse at finding the relevant answers than if you provide small context. Okay, so your job still is, how do I provide the best context possible to this LLM? That's still your job. Okay.
Makes sense. Short and concise. Okay.
Chris.
Yeah, sorry, because I'm pretty new to this concept of RAG applications. Maybe this question is too silly, but how do you decide what context to feed the model with based on a specific question? Or maybe is the context fixed and the RAG application is designed to only answer a specific kind of questions?
So next slide, we're going to talk about that. So just give me 1 second. We're going to see the answer to your question. Mark.
Yes, I just wanted to get a definition. When you're talking about foundation models, are you specifically only referring to like LLMs of like ChatGPT 4, Claude, Gemini, etc., provided by vendors, or can other things be considered foundational models that are like maybe not as sophisticated but are trained on the internet? Only one that comes to mind is like, I think there's one called like the Dilbert. Like, anyway, go ahead.
Yeah, so foundation model usually refer to the GPT series of models, the Gemini, these general purpose models provided by other vendors. Even Llama 4, that could be considered a foundation model. Again, it's not commercial, but that's fine. It's a general model that's provided and we use it, and it's not being fine-tuned on anything. Those are foundation models.
Okay.
Yeah. Matt.
Yeah, I just want to follow up on the Leon's question earlier on about restricting the model's response to the context, like the database. So, for example, the application Notebook LLM, so it's pretty good at restricting its response to whatever source you give it, right? Whether it's like web source or PDF or whatever. So, is that a RAG application, or is there something else going on there?
Yeah. So a RAG application will be something. So if you read RAG, if you go to RAG, it's something that augments, right? Augments creates context. It retrieves, it augments the information that we're going to give the LLM, and then it goes through a generation process. So that is what the concept of RAG is. Whether Notebook LLM does that, I'm pretty sure it does, but Could it be considered a type of RAG, or they're using some sort of RAG? Yes. They're basically augmenting a prompt that you're giving them with a PDF or some information, and they're generating then an answer based on that. So yes, that's a form of RAG. That's what you're asking. Cool. Kevin, let's answer two more. Kevin?
Sure. When you were sort of talking about the simplest thing that could possibly work for like these foundational models, like I was just thinking about the like Titanic data set. Like I think you were saying the foundational models tend to be sort of like simpler than a model that you train yourself, but like in that example, like Titanic data set, would you use like an LLM for that, or would you prefer to train something?
Yeah, you will have to train something. So it's the simplest thing that could possibly work, right? Not just the simplest thing. So yeah, using an off-the-shelf model will be way easier, like taking the whole data set of the Titanic data set and giving it to an LLM and saying, just answer these questions for me. That would be the easiest solution. It's just not going to be a great solution because the LLM has not been trained on those specifics. It's not good at predicting. I mean, maybe the Titanic, for the Titanic would be, I don't know, the Titanic is all over the internet, but you get the idea. For your specific company's problem, the LLM is not going to be great at predicting that type of thing. The LLM is just a parrot, right? It's just going to talk a lot. That's what it does. Doesn't necessarily have predictive power over a use case. So in those cases, the LLM is not going to be a good solution. You're going to have to train your own specific model in those cases. So that's usually the way it goes. Does that answer your question?
Yeah, I think so. And maybe you'll answer that more in the future, but like you're alluding to, like LLMs to be more chatty, and when you need something a little more like precise, like I just want to give you a question, and I just want like sort of a very simple numeric answer back. Seems like LLMs like are kind of overkill.
Not only overkill, it's like they were trained to do something completely different, not to make predictions. Like for example, if I have a data set of plane arrival times, and I want to predict the next plane at what time it's going to arrive, the best thing the LLM can do is literally write code, do that to basically create a predictive model, and then execute that predictive model, and then tell me what the answer is. But the LLM would not know that answer off the top of its head, quote unquote. You've seen that ChatGPT does that in many, many cases. You ask them a question that requires some computation, and you will see ChatGPT do the computation and write code to answer your question, which is great. It's amazing that it does that. But it's other than having that access to that tool, like if it didn't have access to that tool, it wouldn't be able to answer that question because it was not trained to solve that specific problem. It does that a lot with math. When you ask a math question, ChatGPT is actually using an external tool to answer that question. It's not trying to come up with the answer directly. Make sense?
Does LLMs by the definition of the model are not capable to do those prediction stuff, or is it a training thing? You know what I mean. If I start with a blank
training thing. So these are text models. They're not great at doing math.
Okay.
They can produce math by using external tools. And to you, the user, it becomes transparent. Who cares how did they come up with that answer? They're using a tool. They came up with the right answer. Who cares? But they are by themselves not good at doing math. It's like think about you. You're not good at math at all. If I give you a multiplication with 3 numbers, you're going to be lost, but you know how to use a tool to come up with the answer. But it's not about doing it in your head. You cannot do that, but you can use a tool. The LLM is kind of similar, right?
Okay.
It's not going to be good at doing it.
It's about text processing and stuff.
It's about text processing. That's exactly what it is.
Okay.
Yeah. But the LLM is going to be good at. Enrique, that was the last question. Dylan say, I'm going to get back to you guys. You can either write the question or wait a couple more slides, and I'm going to get back to you guys just so I can keep moving. Enrique, go ahead.
Yeah, just a quick question about what you were saying about the amount of context that we can provide to an LLM and how it can be like, it's not going to be as efficient if I provide like the whole book instead of just 2 pages. But I was thinking of, say, one scenario, or what would be more recommended, like if, say that I want the LLM to analyze, probably like I have a team of developers and I want the LLM to see the titles of all the commits that were created during the month so that it can give me a summary of what we deployed that month. I mean, if I provide the whole list of commits, probably going to be a huge list. And maybe the summary that it's going to give me is not going to be as efficient. I mean, is it going to be better to probably do like a pre-processing and provide just like the top, I don't know, like top 20 with like most lines modified? I don't know. But instead of providing the whole thing, what's better in those cases?
So when I say by large context and the LLM becoming less effective, I meant in recall abilities, meaning if you provide 1 million commit titles and you want to identify one specific commit based on a question, the LLM will be less efficient or less accurate at doing that with 1 million commits than if you provide only 10 commits, okay? This is straightforward to think about. It's not necessarily about, it's gonna be less efficient at providing a summary when you provide 1 million versus 10, which could be, but it's not necessarily about that. It's about recalling abilities, the ability to find the needle in the haystack, right? Here is a question, and you answer this question, and the answer is somewhere in these 1 million words. The LLM will be less efficient at doing or less accurate than if you provide a reduced context.
Perfect.
That being said, in your particular example, you might as well find out that also providing a shorter number of commits is better, or fewer commits is better than if you provide all 1 million commits. Make sense?
Yeah.
All right, so how do we get the context? How do we find the right context? Okay, so I'm going to talk about 2 techniques that are very common. The first one is term-based retrieval. Okay, so every RAG has 2 main components. Number 1 is the the retriever and the generator. Sorry, 1 to generate, 1 to retrieve. That's what every RAG does. The 1 to generate, that's usually the LLM. The 1 to retrieve is the one that you implement. Okay, that's the idea. Now, here is an example here. We're using a retriever that is going to retrieve information from documents or databases or whatever it is. And term-based works like term-based, what the word says. You're going to grab a word and say, find me anything related to this word. Like in our case, we wanted the visa requirements. So let's try to find visa and requirements and visa requirements and Spain. Let's try to find those terms in the database. Multiple algorithms do this. BM25 is one that's very, very used, very popular. Elasticsearch is another algorithm that's very popular that will use term-based search in order to retrieve the proper context from a database. Does this make sense so far? It's not just about vector databases. We're going to talk about that in just a second. This is term-based retrieval. Okay? Dylan, go ahead.
Oh, sorry, that was just from the past. It would take you out here, so my question's in the chat.
Oh, okay. All right. Sai, what's up?
Hey, Santiago. Just trying to rehash, right? So I'm just like building a mental map because I'm coming from SE world. So like how we have vanilla-based Docker images, like images, right? So in the dev container, you use Python, like a Bullseye, right? 3.12. Similarly, and then we build our application on top of those vanilla images, right? So our app services. Similarly, we have these foundational models, and in a RAG system, we pick and choose the foundational models. For example, a simple like a prediction by sequence learning, right? So we have a specific foundation model for that, just predicting what the next word is, and then you provide the context using RAG, so that you are basically building a specific fine-tuned system, just for your application, not taking a general big models, so which is trained for the general purpose, right? So is that how is my understanding correct? So
yeah, sounds
okay.
good to me.
Okay.
Okay.
Yeah. So, yeah.
Ahmed? You're
Yes,
muted.
Santiago, sorry, because I'm also new to this field. So when it comes to sensitive documents and confidentiality, because some companies, they are restricting sharing some information with LLMs. So could we consider that it's just like when we do this process, shall we keep just like the confidentiality, or it's just like we can provide the system with the natural data? So this
Yeah,
is my
that's
question.
right. Many companies do not want to share with LLMs the confidential information. So there are two approaches to work around this. So number one is you need to make sure the LLM provider is not sharing your queries. Supposedly, when you have an enterprise account, most providers tell you they're not going to be using your data for anything. I wouldn't trust that at all. Silicon Valley is not trustworthy. They've never been. I wouldn't trust that, because if that information leaks, you are on the hook for it. It's not Silicon Valley. Who cares? So that's one thing that you should do. At least do not use the free or public versions of these chats. Make sure you use a private one. Number two, anonymize your data before giving it to the LLM. By anonymizing, what I mean is, let's say you're sending medical information to or personal identifiable information to the LLM. Just replace all of that by some tokens, send it to the LLM, let the LLM figure that out, come back and replace the tokens back by the original information. So that would be anonymizing. There are libraries that do this, and they're very good at doing this. You need that extra layer before you give that information to the LLM. Yes.
Okay.
Hopefully that makes sense. Yeah. Okay, so term-based. We talk again, two algorithms. When you see them again, now you know what they're talking about. Elasticsearch, BM25. Those are very popular, and people building RAG applications use them. The problem with term-based is that it's very easy to use, but it's brittle. It's not great because you're looking for specific terms. So if I want the visa requirements to go to Spain, the word European is not there. So I'm not going to be searching for any documents talking about European. I'm going to be searching for documents talking about Spain. But if the European Union sets a rule for all countries, I'm going to miss it. I'm not going to find it by using term-based. Why? Because the word Spain is not there, right? So you get the idea why this is brittle. That's where embedding-based retrieval comes in. And this is the most popular one. This is the one that most people talk about. Okay? It's not the only one. I just want you guys to understand that term-based retrieval is also very important. Good RAG applications usually combine both. But embedding-based, let's talk about that one for a second. Here, you need an extra step where you are going to get your knowledge based and you're going to index your knowledge base. You're going to generate embeddings for all of your documents, and you're going to save them in a vector database. This is what that process will look like. Okay? So going back to the visa requirements, we will get the government database, all of that information, and we will index all of that information, which is what you see here in this dotted box. Okay? So we're going to get the knowledge base. We're going to split all of those documents. I'm going to talk about splitting in just a second. Just trust me. We're going to grab all of that information, and we're going to take it through an embedding model. Okay? That embedding model is going to produce vectors of numbers, and we're going to store those vectors of numbers into a vector database. And the RAG application then We're going to take a query coming from the user. We're going to pass it through the embedding model. We're going to generate a vector of numbers that represent that query. And then we're going to use that vector of numbers to search the vector database for anything that is similar. And that will give us the context that we want to pass to the model. So the extra step is that indexing process that you have to do beforehand. And then you will retrieve from the vector database. Now, some of you might be asking yourself, what the heck is embeddings? What does that even mean? Okay, just an embedding, think of it as a numerical fingerprint that represents a concept. I like to think about them like coordinates, like latitude and longitude in a world. They're coordinates. And when you look up in the map for those coordinates, you're going to find an idea, a concept. So what we want embeddings to be is if we get two similar concepts, we want them to be close to each other. When we get two different concepts, we want the vector numbers to be far apart. So if you look at this, imagine that I can get an image and take it through an embedding model, and imagine that image is about the Eiffel Tower. And then I can get a document talking about the Eiffel Tower, and I take those two through an embedding model, and the vectors, they are going to be similar. They're going to be close in space. See this vector representation? Well, those two concepts, hopefully, they're close because they're both talking about the Eiffel Tower. Okay? The closer two embeddings are, the more similar the concepts are. Okay? Does that make sense? Mark.
Can you go back to the overview? Yeah. So we use the embedding model to get this digital fingerprint from the query, and then we use the vectors to create the context or to receive the things from the knowledge base.
Let's see, very simple example. I have a data, my knowledge base consists of three objects: a notebook, a phone, and a fidget. Okay? Hold on.
Yeah, I follow you.
These three concepts, and I'm going to generate a vector. That's what the embedding model is going to do for me. So I'm going to generate a vector for my fidget, for my notebook, and for my phone.
Yeah.
And I'm going to store those three vectors in a database.
Yeah.
Now I have a pen. This is the query. I want to return information from that vector database that's related to a pen. So I'm going to take this pen and generate the vector that represents this pen as a concept. I'm going to ask you this: notebook, phone, fidget. Which one do you think is going to be closer to the pen?
Either the phone or the notebook.
I would say it's probably the notebook. Well, it depends on the context.
Yeah,
right?
you can write with a phone, you can write with a pen.
At least it's going to be the order, right? It's going to be the order like this, right?
Something like
Notebook
that.
first, phone second, right? So now I can grab, let's say, the top one or the top two and give it to the model and say,
okay,
here's
now,
the query. This is the context.
So now, Santiago, because I might not have expressed myself, do I give the original items from the knowledge base to the model, or do I generate surrogate data by the retriever from the vector base? Because I don't see a line from the knowledge base to the model, so I was confused.
Oh, I see what you're saying. So the vector
that looks for me like generating from the vector some surrogate data.
Oh, gotcha. No. So the vector database will store the vector and the original content as well. So what you the model is the original content, not the vector. right? The vector is just for indexing purposes, for you to find what the content is. Make sense?
Okay, it's not a surrogate data context generator thingy.
Just the actual content.
Okay.
Arun, go ahead.
Hey, hi. So how different or similar like the embedding model and the model that you're actually like using as your frontier model? How different or similar they have to be? Like, do they have to be using the same embeddings? What if you use different one? Maybe you can just talk about like what are these different types of, because I've heard that there are different parameters of embedding models as well. So just want some sort of details on that. Thanks. Yeah.
Gotcha. So these two embedding models have to be the same, obviously, because you're using them, one to index and the other one to retrieve. So these two embedding models, they're the same model. They are not necessarily the same or related to this model that you have right here. They're different things. So this model here could be GPT-4o, okay? This embedding model was trained during GPT 3.5. It's not GPT 3.5. This is an embedding model. Different goals. It's not an LLM.
Yeah.
It's an embedding model. But these two should be the same model, right? You don't want to index using an embedding model and then retrieve using another embedding model. You don't want to do that. It's not going to work well. Make sense?
Expect the same version, ideally?
They should be the same exact version. Yes.
Okay.
Yeah.
How do you like, I mean, is there like a playbook or something where you decide like which, I mean, depends on your use case. I assume you're going to give that answer, but is there some sort of detailing or like some kind of text available where you can see which embedding model should you choose based on like some use case or something?
Yeah, so number one, these companies also provide general embedding models, and usually the latest and the greatest that they provide. You can also fine tune an embedding model. So the embedding model is the one that's going to generate this. Okay, this right here it's literally what I get. If actually, let me show you. This is one of the last slides. So let me share my screen here, or a different screen, and I'm going to show you how to produce something like this. First, let me explain what this is. These I generated using Cohere's embedding model because they have a playground and it's easy. Actually, I'm going to show you at the end. Just trust me on this for a second. Cohere has a playground where you can test their embedding models. Okay, so I gave Cohere these words. Okay, so 10 words. And you can see the words are France, Paris, Italy, Tokyo, Rome, Japan. You can read the words. And I asked the embedding model to generate vectors, and then represent those vectors in 2 dimensions, okay? Embeddings are vectors, are multi-dimensional vectors. So in the case of Cohere, I think it's like, I don't know, more than 1,000, 4,000 dimensions, I think. I don't remember correctly. But here it's just represented in 2D space, right? X and Y. And this is what you get. And I don't know if you noticed this, but I gave it 10 words, and the embedding model represents closer the country with its capital. See, Madrid is closer to Spain. France and Paris are close to each other. Tokyo and Japan are close to each other, because the embedding model has a lot of knowledge about the world, so it's able to produce similar vectors for similar concepts. Okay? So if you remind me during the Q&A, I'm going to show you the tool so you can play with this and understand. And it's super cool because you can type anything. Like you can type foods and then cars. And when you produce the embeddings, anything related to cars is going to be close to each other. Anything related to food is going to be close to each other. Okay? That's how the embedding model will work. It will produce similar vectors for related concepts, and these similar vectors for concepts that are far apart. Okay, make sense?
Okay, just one last thing. So when a user actually puts a query inside like an application, let's say if you're using RAG, are we going to turn the whole sentence or whatever, like the whole query into an embedding, or are we going to like chunk it and then like how do we make sure we select the correct text and then pass it? How does that work? Yeah.
Right. So now we get into chunking, which is the next thing. But chunking is usually not done on the query. Chunking is usually done in the knowledge base. So remember, the knowledge base is the book, right? So I want to index this whole math book. So whenever somebody asks a question about math, I can find the, let's say, the chapter or the section of the book where the answer is really, really quick. That's where chunking goes into. Like, how do you subdivide this book? How do you split it? Because it's not about generating a single embedding. That would be stupid, right? Why would I want to do that? You have to divide it somehow, okay? So that's where the idea of chunking comes in. So here is one example. You have a knowledge base, and you're going to have a step that will split the knowledge base into different chunks, okay? So the chunks could be for a book. A chunk could be an entire chapter. That would be one chunk. That's just an example. Or it could be a page of data. So chunks will be based on pages. Or it could be a few characters or a few words, right? Whenever you're starting with RAG, a recommendation is just to start with, let's say, chunks of size 1,000 characters. And that's good enough. And then you do some overlapping in your chunks, right? What is a good chunk? It really depends on your use case. But the better your chunks are, the better results you are going to get. Does that make sense?
Yeah, it makes sense. But I'm just thinking, because let's say if we do like in our knowledge base, the chunks are based on some paragraphs, so maybe 2-3 sentences, and whatever user is asking is maybe 3-4 words or something. So how is it going to be mapped in the embedding space so it is closer together and we fetch the correct paragraph or something?
Yeah, so let's say you are chunking based on paragraph and you have 1,000 paragraphs, and then the user asks a query with a few words. When you create a vector of those few words, you need to find through all of the vectors of every paragraph and find every single one of them that's similar to the query. And hopefully, that by grabbing, let's say, the top 10 similar paragraph, most similar paragraphs, hopefully the answer to your question will be in those top 10 or top 20, whatever the number is, top 4, whatever the number is. So that's the idea of the process.
So there's no dependency on the length of the query. Like in embedding space, it is or everything is similar, like as in that way.
Yeah, no, there is no dependency. It doesn't matter that you are chunking by paragraphs and then the query is just a few words. Doesn't matter. Okay.
Cool. Thanks. Yeah. Thank
you. So here is the chunking. Notice that I'm adding here something, which is the contextualization of chunks, which is usually a good practice when you're creating chunkings. When you're creating chunks, one thing that you could do is I'm going to generate chunks, let's say, based on paragraphs, but then I'm going to augment those chunks by extra information to improve search later. What would that be? For example, I'm going to create a chunk, which is a paragraph, and then I'm going to add to that chunk information about the chapter, the section that I'm in, the name of the book, or the number of the page, etc., etc. And that will be my chunk. My chunk will be the original text of the paragraph plus all of the metadata that I'm grabbing. I'm going to take that and create, I'm going to generate, using an embedding model, I'm going to generate the vector that's going to go to the database. And that will be better off later to find relevant information. Mark.
Might it make sense to create like hierarchical chunks, saying per paragraph, and I chunk also the chapter as a whole, and give some other metadata for that?
Yeah, you could like create chunks at the level of paragraphs, but you can also like create it like a whole chapter as a whole.
No, I mean it's for the same embedding model. Saying, okay, we have different levels of detailing in which we represent to the embedding model.
Yeah, you can also do that. The point is, I don't know which one is going to be better. You're going to have to try your application depending on the answers that you want to answer. one is going to be better than the other, or maybe a combination of both is the right solution. You're going to have to experiment with that. Yes. The size of your chunks or how you're going to split your information is a use case by use case decision. Not one decision is better than the other one for all use cases. Like for some use cases, chunking at the paragraph level is better than chunking at the section level. For other use cases, you need to use like a complete different heuristic to decide on your chunks. Some people create knowledge graphs, and that's how they chunk. It's very different than just getting just a paragraph.
Are there already some established heuristics, or it's
They are.
really art form still?
Yeah, they are. When you go to any of the libraries that allow you to build RAG applications like LangChain, they have a whole library of ways of chunking documents. You can
And
just
recommendation when to use what?
I guess, yes, when you read the documentation of each
That's what I mean with heuristics. Is it still an art form, or are already there some knowledge out there what is typically for certain kinds of applications the right thing to do, or a good thing to do? Maybe not the best, but
there should be some rule of thumbs out there depending on the application that you're going to build. There is also a lot of intuition about how you are organizing the information in the first place. Like if your information is well organized, and let's say you are doing it for products and you want users to ask questions about products, right? How would you organize that information? Well, maybe you want each embedding to represent the product, and all the information related to a product will be under a single embedding. That's the way you want to do it. So that's the best way for your particular application based on the queries the user is going to be asking. But if you want something that's more general, then maybe by paragraphs is the best way. You get a ton of information in a document that is not necessarily related to one another. You need to chunk by paragraphs, right? It depends on the information that you are embedding, how you're going to be splitting it. Guillermo, what's up?
Yeah, when you say contextualized chunks, and that context is going to be vectorized too, or that you mean that you should add it to the metadata of the vector database? Because sometimes if I have page 1, page 2, that doesn't add value to the search, really.
That's correct. So the number of pages is not going to add value to the search, but there might be information that you can extract that will add value to the search, like the name of the chapter where that paragraph comes from, right? So the whole idea here is, instead of just contextualizing the paragraph, think about what other information you can find that by adding it to that paragraph will add value to the embedding search. Like, here is a paragraph about logarithmic equations, and this goes under derivatives chapter. I don't know why, but it goes under the derivative chapter. So that will add extra information that might help you zero in when the user asks something. It might help you signal that this paragraph might be relevant. Okay. If you go, I think Claude, they recommend doing something on top of, actually, I have the link here. I'm going to share this link, and you're going to see what Claude recommends, or Anthropic, not Claude, the company behind Anthropic. They recommend doing this. I don't know, you might be seeing my screen. No, you're not. I'm going to share this in the chat, which is how they create that extra context by using an LLM. So they grab a paragraph and they use that paragraph to using an LLM to summarize it and to include additional information from the source. And that's the chunk. I also work with a different company. So I've worked with a company called iLevel, and the reason I mention them is because they have one of the best, if not the best, RAG systems that I've seen out there. And their retrieval process and their indexing process is really, really good. It's basically because the way they chunk and the way they extract metadata from the document is amazing. It's not just about chunking that paragraph. It's about everything else that they add to contextualize that paragraph. That's what they vectorize. Hopefully that makes sense.
Thanks. Yeah.
Can you
Siri.
That's part? Sorry to interrupt.
Yes. No,
Yes, Santiago, could you elaborate on why we can have different embedding model? As I understand, when we're training LLM, they like we train weights for concrete representations, like within this LLM. How come that we can have different vectors? Aren't those from different like distributions, different spaces?
So what I said about not having the same, or you need to have the same embedding model, is these two embedding models for indexing and for retrieving. Those two have to be the same. If you have two separate embedding models, the vectors provided or generated by the first embedding model might not match the second embedding model. So you're not gonna.
But that's not exactly my question. After we did retrieve, output is vectors, right?
No, the output here, the retriever will return raw data, not vector.
Oh, okay.
The vectors are
text,
to do the
basically.
matching, right? So the vectors will be just, so a vector database does not only store vectors. It stores vectors and the original data, right? So if we
So
are
the context in output is text, right?
It's text. It's just
Oh,
regular
so-
text
Cool.
that you retrieved by getting vectors. So imagine that what I'm giving to the model is this is the original query, and these are the 5 paragraphs that are the most relevant to answer this question. That's what you give the final model. You're not showing the model numbers. You're
Got it.
showing the
Thank
model text. You're using the vectors just to retrieve and find the similar paragraphs. Make sense? Cool. Leon, what's up?
Maybe more of an advanced topic, but how does embedding like images or tables and PDFs or, more, I guess, kind of more, not just like paragraph text into this kind of stuff, and would a RAG system be able to reference that and give you links back to the original data?
So how would the RAG system will give you a link back to the, so first of all, I don't know if this is related to what you just said, but you can, with an embedding model, you can also pass images, you can pass audio, you can pass anything, and the embedding model will produce a vector. And if you have an image of a concept and a text talking about that concept, the embeddings will be similar. And if you want to learn more about that, I'm going to keep answering your question, but if you want to learn more about that, let me show you here where you need to go. So find the clip model, okay? And this is from OpenAI. This is old, okay? So this is from 2021. But if you read the clip, how they did clip, basically that's what they're doing here. They're connecting images with text, and they're able, through clip, they're able to produce embeddings that are similar, regardless of the source of the data, if it's images or text. Now, after you do the embedding, what you stored in the vector database is, this is the index or the embedding, the vector, and this is the original source of data, the paragraph or whatever that is. So anytime you can retrieve from the vector database, whenever you retrieve the top 5 embeddings that are closer to a concept, you also retrieve the original source of those embeddings. Where is the data coming from? Does that make sense?
Yeah, I guess just like if you're trying to like mimic a business's knowledge base, a whole business's knowledge base, businesses don't just store just text in words. They have PowerPoint presentations, they have, lots of images, lots of charts, lots of other modalities. How are you grabbing information out of those modalities to be able to have a conversation with and grab the real actual data out of those? I guess that's a better way to explain.
You have to index all of those modalities. So let's say you have PDF documents and you have folders of images and you have Excel spreadsheets. The indexing process will process all of those modalities, regardless of where they are and how they are. And the vector database will include the original source. Like part of what you are embedding is a JSON object that says, this is PDF file such and such, paragraph 3, page 27. That's the information that you are embedding. So anytime when you retrieve the data, you can see exactly where that information is coming from. Oh, this is coming from this file that's here. This is this image in that database. So, but you have to index all of it. So you have to process all of it beforehand before you can actually use it using embeddings. Make sense? All right, John, go ahead.
Yeah, you mentioned a few times that you need to see what works best for you in terms of RAG, like chunking size and whatnot. But how do you actually evaluate a RAG application? What is the best way? Because we've run into this issue at work a bit, that we're building an application that is retrieving some data from huge documents, and there's a bunch of like libraries that offer metrics. You can run that on LangFuse or whatnot, but that doesn't really give me much. It's not very meaningful for me. So, what's your take on that?
So, number one, at a high level, RAG applications are usually evaluated based on their recall, their recall capabilities. So, how capable they are about finding specific context that matters to answer a question. Like you said, many libraries offer some of this metric out of the box. The best way, in my opinion, to evaluate these applications is using error analysis, which basically starts by you identifying what you care about. And based on that, finding ways to measure what you care about. So what are the questions that are breaking your system? Categorize those questions and go through the process of improving your system to improve the answer with those questions. Session 3, I'm gonna get blue in the face on Monday talking about error analysis. That's one of the main topics here that you're gonna get. You're gonna lead the program understanding how to do error analysis. Hopefully, that's the way I would do it. If you want something before now on Monday, just look that up. Error analysis LLMs. You're gonna get plenty of information online. Yeah.
Follow-up question. So these metrics, they're worth something, right? They're useful actually, or they're just random numbers that we shouldn't really care about. Like out of libraries like Ragas or something.
Metrics are useful, but not necessarily the main thing that you should focus on. Like, who cares what? I'm trying to think of something like comprehensiveness. Like, who cares? My company wants to make money. Who the fuck cares that my models are comprehensive in their answers? Like, that doesn't move the needle. What I want is number of issues closed. What I want is number of customers who paid. Those are the metrics that you should focus on. That's what error analysis will help you identify and work towards. Comprehensiveness and relevancy and recall and all of that are great to maybe write papers, not gonna move the needle of business.
All right, thank you.
Mark.
So what I understand on a very abstract basis, the embedded model is just another model, like an LMN or a neural network or dysentery or whatever. So that means we stuck already multiple models into our pipeline just for the model. We might have for the classificator, for the LMM. And we have additional models maybe in the pre-processing step to do stop for us. Doesn't that mean that our need for data explodes because we have now on a higher abstract level a big complex model consisting of different models that do different things in the pipeline? That means our test and training and validation data I feel would go the same way as dimensional explosion would bring us. You see what I mean? You have many models and their models are not independent from each other because they form together a system. And
so I hear you. I'm hearing you saying words. I do not I haven't been able to make the connection of why the conclusion that you're drawing, I don't see it. Why? Because you're using multiple models, your data needs will explode. I don't see that connection though.
If you have 3 models in your pipeline, and those models form a system, right?
Yeah.
The pipeline forms from the 3 models one big system. So in the black box, it's a model with much more complexity. And so I would expect, when I'm looking in the black box, from the black box perspective, I would each of those small models give a multiplicator to the data I need to train, because I have to train the whole pipeline through.
Oh, but we're not. So I don't know if you're referring to this RAG thing. We're not training those models. Those models are pre-trained on the internet. We're just using them. Okay, so the embedding model I'm not training.
Okay.
That embedding model I'm using an off the
So
shelf.
we use it. This is a piece of software. It's not a model where we can have data flow.
That is correct. It's not a model that we train. It's just a piece of software that we're using off the shelf.
Okay, understood. Thank you. That helps.
Oh, what's up?
Hi, Santiago. Can we go back to the last slide that we were looking at just then?
Yes. Let me just share my screen here real quick.
So my question is, do you have a recommendation for the optimum vector database? Like, does it have to be like relational, non-relational? What are your thoughts there?
So vector databases became a thing when this whole model started getting popular. All of a sudden, a bunch of companies started releasing vector databases. That was the only thing that they were doing. Right now, vector databases, like every regular database, will include the ability to have vector store vectors. So MySQL does it, Progress does it, or you can also find a dedicated vector database like Pinecone or whatnot. My recommendation is use whatever you're using already. If your company is already using MySQL, don't install a separate vector database. Just use MySQL vector database capabilities. There's nothing fancy about vectors. It's just supporting specific algorithms to search really quick through vectors. If you're interested, look for FAISS, FAISS. That's sort of like the algorithm that's powering all of these that will let you go through or identify similar vectors really quick. Any database vendor will implement it now. That's what we should use.
Okay. Yeah, I use Postgres, so that's good to know. Thank you, Santiago.
Progress, you can install an extension for Progress, and that will let you use vector, vector embeddings inside. Yeah, you don't have to do anything else. Emla Wally.
Yeah, about indexing. So is it the same indexing that used to be done like in the traditional SQL Server, for instance, databases and stuff? Is it the same process?
The indexing here is like a separate process. It's the same idea, you're indexing information, but this would be a separate process you will have to run to get your knowledge base, chunk it. That's what the splitter will do, split the knowledge base into chunks, and then generate embeddings, and then store them in your database. So this is a separate.
Okay, appreciate it. Thank you.
Cool. Let me go through the Q&A, and let's try to get, I'm going to start from the bottom of the Q&A towards the top, so I keep more information relevant. How interoperable are models? For example, can OpenAI model be hosted on Google Cloud Platform? That is a great question. I'm guessing if an OpenAI model, you mean like the open source model they just released, then yes, you can host that anywhere. So yes, you can do that. But for the most part, Google hosts Gemini on their hardware, and OpenAI hosts their GPT series of models on their hardware. But open source models are meant to be distributed and are meant to be deployed anywhere. That's what they are, open source. How long should be the chunks to get the embedding in a RAG system? It really depends on your application. You are the judge for that. So you can try having chunks that are 1,000 characters long or 1 million characters long. You have to try and decide which one is best for you, okay? So it really depends on your knowledge base and your application. So there is no rule of thumb there. Language questions. How many data compute I need to fine tune an LLM to make it better in a language other than English? Well, it really depends. If you are fine tuning like a foundation model like GPT 3.5, OpenAI hosts the fine tuning process. You only provide the data. OpenAI hosts that. Okay? So you don't have to worry about hardware. You have to pay the bill, but not worry about hardware. If you want to understand how expensive that will be to fine-tuning on a different language, it might take a lot of data. I'm not sure how much. I haven't done it, but it's going to take a lot of data to get an LLM speaking on a different language and speaking correctly. Okay? What I've heard about people trying to do this is that the main problem is the availability of data in that language, okay? So I'm assuming there's gonna be a lot of data. If you want to fine tune an open source LLM, what the hardware that you need is the one that hosts, like how big is the hardware depends on how big is that LLM. Fine tuning a 7 billion parameter llama, it's way easier than fine tuning a 400 billion parameter llama. You need to, it's 400 billion versus 7 billion. There are many, many companies that allow you to do fine tuning without you having to pay for hardware. Many, many companies out there. Monster API is one that comes to mind, but many companies offer services to do this. Does it make sense to translate context and query into English to get better responses, since most models have much more data in English to train on, and then translate back? That could be a solution if you want to work with a different language. So you will get the query from the user, you will translate it in English, and then you will do the embedding and all of that, and then translate back if you wanted that information to go to the user. That is a potential solution. I've heard about this being done, yes. How do MCP resources differ from traditional RAG systems in terms of capability? In what scenario is MCP a better fit than RAG? And are there cases where RAG is the better choice? So MCP and RAG are different things, completely different. RAG is about augmenting context. MCP is about giving models access to the external world. You could use MCP to retrieve information, but the question is how? How are you going to select what information to retrieve? MCP does not speak about that. RAG speaks about that. MCP, you could use it to execute a task. RAG does not speak about that. So again, they're very, very different. They're not related at all, okay? So very different concepts. We're gonna talk about MCP a lot in session 6. Why MCPs are better than just integrating with APIs. At the end, both are tools. So that is a great question. Perfect for session 6. I'm gonna try to talk about this really, really quick, okay? So the problem with APIs is, let's say I want to connect my model to an airline API, okay? Because I want to build an agent that books a trip for me. If I connect it to Air Europe API, I have to build that connection. I have to build that. It's not just telling the model access the API. No, it's what is the format that I need to translate my information to, what are the parameters. I have to build that communication. But I have to do it with American Airlines. I have to do it with Iberia. I have to do it with every single airline API, which are all different, okay? But that's for my agent. But my cousin, he's also a developer. He will want to do the same thing, and he will have to build the same connections all over again. So what that means is that if you want to connect directly to APIs, there is an N times N communication problem. With every model that you're using, you have to build a connection to every API that you're using. So if you have N models and M APIs, you have an N times M problem. 3 models connecting it to 3 APIs will give you 9 different connections. MCP solves that problem because simplifies the problem. So now I don't care about the specifics of the APIs. I only care about implementing the MCP standard. And the people who are the airlines can just provide their MCP server. And now every model that implements the MCP standard can connect to every API without having to code specifically for APIs. So that's just one of the advantages. So for you, Mr. John Doe, you can connect directly to an API, that's fine, but that does not scale, okay? The second problem is that when that API changes, guess what's going to happen to your code? It's going to break. When that API releases a new function with different parameters, your code is breaking. But with MCP, it's not, because the model will adapt automatically. We're going to talk more about that in session 6, but it's way better, I promise you. Let me go to the questions really quick and then come back to the Q&A. I mean, let me go to the open queue and then I'll come back to the Q&A. Lucas, what's up?
Hi, Santiago. Sorry, but I have a question regarding the first few slides. When we talk about the 100% of the data and training, validation, and test, when working in places that have well-separated environments like development, QI, and production, and have many teams involved as cybersecurity engineers and security teams trying to not leak the security and so on. When building the models, does using synthetic data has any sense in this case? And the follow-up is, does one have to go, how much time back does one should go to have a sample for development environment?
Right. So the first question is about synthetic data and whether that makes sense to use. So again, this is a use, case by case basis. Synthetic data is very helpful when it's very hard to collect specific examples of your data. For example, Tesla, famously, they talked about this publicly. They have a game engine to generate synthetic images. Just very realistic images to train their models. Why? Because finding somebody riding a bicycle in a highway is very rare, but they need to prepare their cars for that. But if you wait for that case to happen, what's going to actually happen is that the car is going to kill the person doing that stupid thing. So you need to generate data that's fake, synthetic, if you want to train your model. So synthetic data is used to augment your data sets with data that otherwise is going to be very hard or expensive to generate. That makes sense to do, but it really depends on your use case. Do you need it or not? Really depends on your use case. Does that answer the first part of your question?
Yeah, it's more regarding the security team don't want to use production data in development environments, but it's currently a fight we have in between teams. We need real data in order to train models that predicts better results.
That is correct. So that's another way of using synthetic data. We usually call that anonymizing the data, but it's the same idea. So instead of using real data in a development environment, you could just use fake data. So it's not related to actual people, but the data it comes from the same distribution than the real data. That's the important thing. If Tesla uses bicycles riding on highways that don't look like real bicycles riding on highways, their models are going to learn the wrong lesson there. So you need to make sure those images are very realistic. Same to you. You need to make sure the data you generate is very realistic. Cool.
Okay. Yeah.
Can you repeat the second question?
Yeah. So we're in the development stage of a system. We're trying to take a bunch of months to the development team to has to and train the model. So it is a window that we are trying to figure out if there is a window of 6 months that we should be moving around, or maybe a year before to have the data to develop and then have the production data insert to the models.
Yeah. So in session 6, I talk about 2 experiments that you can run, and one of those experiments will give you a hint how far back you should go, to grab data to train your model. In short, think about this. If it takes 6 months, take 7 months, take 8 months, train your models and compare and see which one is better and go by that. Very easy. Just try that and see how far back you should go for your model to be good.
Yeah, it's like the experiment you says of chunking 10%, 20, 30, and 40, and you said,
it's like doing that. It's like doing that, yes. But we're going to cover it in session 6, like very exhaustive.
Thank you very much.
Gary. Gary Zavaleta. No? Well, I'm going to go through the questions while Gary figures the thingy out. So we do not train the embedded model, but we at least experiment with splitting. Will splitting meta parameters optimize independently from other things we can tune in the pipeline?
I'm still on the complexity thing. We have many screws we can adjust in our pipeline, and I'm asking, okay, is there complexity between those things? Will the splitter thing optimize independently from my preprocessing and other stuff in your experience?
I'm not sure how to answer that. Will the splitting in...
Yeah, think about, we have different ways for splitting stuff, and we experiment with that to find, okay, which splitting works best for our problem. And we have pre-processing steps and we have training steps for different things in our pipeline.
Correct.
In your experience, is the splitting having some work improves independently from tuning other stuff?
Yeah, it will be. So splitting, how you split is a thing that you need to tune and you need to improve, and that's independently from anything else. Yes.
Yeah, so there no this kind of splitting might work differently for that kind of pre-processing.
That is correct. Yes.
Okay. Thank you.
The question I'm gonna go to, after answering this question, I'm gonna go to Dinesh. Gary, and then Dinesh. So the question is adding memory and fetching it, providing to LLM in context to fetch answers. Can we say this is also RAG? So context construction, the context is part of what we consider the memory of an LLM. And when we talk about agents, we're gonna see that memory is one of the main important components. Well, context is part of that memory. So anything that is retrieving and generating, that's RAG, okay? Anything retrieving and generating. But this is just semantics. It really doesn't matter. But yes, retrieving and generating is RAG. Retrieving from memory is like, if you're gonna use that information to generate something, yeah, you could consider that's RAG. Gary.
Hi, can you hear me okay?
Yeah, I can hear you.
Yeah, okay, great. So I have 2 questions, or maybe one is just one observation, and the other one a question. So you were talking about the LLMs are not great at math, but well, it's funny because I was watching an interview. It was Geoffrey Hinton. So he was explaining about that neural networks apparently are great at making analogies between all these layers. So basically, they're not just great at coming up with the next words, right? So that was kind of the summary. And I think 2 weeks ago, one of these model, I think it was Google DeepMind, they won a gold medal in a math contest. So all of that is apparently, yeah.
I think they got a gold medal. I think both of them. OpenAI got gold medal. Google DeepMind also got gold medal in these competitions. The question is, are the models doing it, or is the combination of a model with tools? That's what I don't know. They haven't said. It might be that this model have gotten to a point where just because of all of the step-by-step thinking and all of that they're doing, they can do more of the math. I suspect they're also using tools to do all of the math, which is equally impressive. I'm not trying to get anything away from these models. It's amazing that these models can solve those problems. And who cares how they solve those problems? Like, I'm not gonna be picking fights here. Oh, but that's not the LLM that's doing that. It's an LLM plus another LLM that they're working. I don't care. So what I'm saying is that the transformer architecture, like the core of these models, it was not thought to solve math problems, and it's very hard for that transformer alone, the way it is, to solve these problems. Whatever models these people are using to solve those math competitions are way, way more complex than the regular LLM, the way we think about. We just don't know how they are internally, because they're not going to tell us either, because they will lose. I mean, if they tell us how they're building these, they will lose all sort of advantages. Yeah, does that make sense?
Right. Yeah, right. Until they release how they're doing it, then we don't know. We just,
by the way,
which is also in line what you said, do not trust Silicon Valley.
But keep in mind, I'm not saying they're cheating, or I'm not taking anything away from them, okay? I just don't care how they solve this problem. The fact is, if they're solving this problem, it's really impressive. If you give me all of the tools in the world, I'm not going to solve those problems, okay? I'm not going to get a gold medal. Give me access to the internet and all of the tools in the world, I'm not getting gold medal, okay? So the fact that these models do that is just very, very impressive. But also, there is another fact. If you go to the best model that ChatGPT has to offer right now, and you give it like a long multiplication, ChatGPT will write code to solve it. It's not gonna just output the answer. It's going to write code to solve it, which is amazing. Again, but it has a tool that knows how to write code, how to execute that code, how to grab the final answer, and how to give it to you. That's my point. The model itself is not great at solving it, but the model knows how to get to the answer. That's the idea.
Right.
Dinesh.
Yeah, sorry. I got my other point, which was my question on RAG.
Sorry.
Well, all of this is very interesting and practical, what you're explaining. I can understand it because I went through the process and built my own. So I suggest everyone, if you want to understand, there's a lot of information there. So if you don't understand, I think the best thing is that you build your own. Start baby steps, and you will understand it. So I built a few of them, but I'm also build a few for my company and an enterprise level. And I was also looking for vendors, particularly for solving text to SQL, right? So basically what the job of an analyst do, right? So you have a database and you want to talk in natural language, and then you want to get an answer. So you have the SQL creation in the middle. So I haven't found so far, a year ago, let's say, a solution that was accurate enough. And in this case, I think accuracy is important because you don't want to give a system to a CFO, CEO, any of your user, right? To give you a wrong answer, to make a wrong decision, right? So that's why I started playing with that, and that's how I got into it. But I'm still a work in progress. So I wanted to ask if you have experience with this kind of system. Not necessarily for documents. I use RAG, all of that, but for making SQL.
personally, I have not worked on building these systems, but I've seen a couple of systems that are pretty good at translating English into specific queries to run on the database. Two of them that come to mind are MindsDB, and the second system is PromptQL. Both are very good at translating English into database queries. That's not the only thing they do, but that's one of the things they do. But I have not worked on systems like this personally, no.
All right, thank you.
Dinesh.
This is a question about XRAG. So you call a system RAG only if it's like a document, like split and store that in the vector database. For example, if I have some use case where the customer asks about something about the company, so if in the real time, if it goes to the private endpoint and then gets some real information and then retrieves and then adds and gives, even that is still considered as a RAG. And then how do you? But for that, like we don't have the vector database pre-built, right? But for the document, we
that's fine. Turn-based. Remember that we talked about that there are two ways, like this one here. This is a retriever, and it's using term-based search to retrieve the information. There is no vector database involved here. Usually, production-grade RAG systems use both. Like how would you use both? Well, you get the query from the customer, you do term-based, retrieve 5 documents, and then you use embeddings to retrieve another 5 documents, and you provide all 10 documents to the model.
Okay.
So that would be a very good way of building this. Yeah.
Okay. And then, so basically you will give like a Swagger file to this particular model and it knows which API to call, and then it retrieves that particular information and then it adds it. Okay.
Right, that would be the idea, right? You will always, you get the query and you call a tool that, hey, search my knowledge base using these terms from this query. And again, you would use an algorithm that either Elasticsearch or BM25 or any other term-based algorithm, and you will retrieve documents or 5 documents, a number of documents, and then you will call a different function that will do the embedding search. Yeah, and then you will put all of that together here as part of the retriever, and you will pass that context to the model.
Okay.
That's it.
And yeah, based on your experience, so whatever the LLM model which we are developing these cases in the market, it's 100% everything is RAG based, and then they have some sort of like retriever and this knowledge, or
yeah, all of the RAG-based applications are going to have a component to do the retrieval process. That's what you're asking. Yes, all of these.
Yeah, thank you. Yeah.
Cool. Let me go back here to the Q&A. There is a question here I think is interesting. It says, what actually causes the hallucinations in LLM? I looked this up, but the answer seems very vague and unsatisfactory. Honestly, I don't know exactly. Like, I think you probably know more than me about this. I can tell you that these models, because their structure, they are going to tend to answer a question. They don't always know what they don't know. So I can give you a very simple example. Forget about LLMs for a second, but when you build a neural network and you ask it to classify an image into whether it's day night or not that one, but imagine an image and you want to classify what animal you see. And you train that LLM with 3 animals, cat, dog, and chicken. If you show it a picture of a horse, your neural network only knows how to classify 3 animals. But now you're showing it a picture of a horse. What do you think the neural network will do? It will give you, out of those 3 animals, the one that looks the more, the picture looks the more of a cat or a dog or a chicken. That's it. That's what it's going to be able to do. It doesn't know, it wasn't structured to come up with an answer that is not part of the training data. But you're asking it to do it anyway. We human beings, we have the ability to say, I don't know. We have the ability. The model does not. So hallucinations come from that.
when you're asking a question and the model does not know better. Okay? The model does not know how to answer that. It's going to try to force an answer of a topic that it doesn't know, and it's just going to hallucinate that. Okay? It's just the way, technically speaking, the model was trained. There are ways to mitigate hallucinations, like teaching the model to say, I don't know, but it's not easy. We haven't gotten to a point where we can actually do that. I don't know if this is going to be good enough for you. That's the best I've got for this. So let me answer more.
Yeah, Santiago, that makes sense. My specific case was like, I was so shocked that it got it wrong, because it was like me asking it the historical, like the age of a historical figure when he performed this thing, and then it got the age wrong, and then I said, oh, actually it's this is the correct age, and then it was like, oh, I'm sorry, and I was like, this is AI, you know.
They love to do that. You correct them and like, oh, you're right. Remember, these models they look good, but they're stupid. They don't think like us. And unfortunately, we tend to think about them like humans, and we get surprised when they don't act like humans, right? We're like, oh, this is so stupid. They're just machines. They're trying to produce words based on training data and algorithms that are not deterministic. They're very good, but they're not humans. So they do that type of stuff. And you can correct them 10 times, and it will do 10 times. It would say, oh, I'm sorry, you're right. This is the actual answer. I'm like, really? Which one is it?
Yeah.
So what are best practices currently to dig the accurate data, minimizing the errors? Best practices are embeddings on term-based and combining them both. Those are the best practices that I know of. So if you're building a RAG system, build term-based retrieval, build embedding-based retrieval, and combine them both. Now, within those two areas, there are many, many things that you can tweak and optimize to get better answers. Like in embedding base, for example, you need to optimize how your chunks are going to be, like how big they are, how much information you're going to chunk at the same time, what is the metadata you're going to include, et cetera, et cetera, et cetera. So there are many, many things that you can tweak here, but that's just best practices there. How does RAG pick information from the source that is relevant to the query? I think, Sandeep, I'm not sure if you're here. I think we've answered that many, many times already. I'm not going to answer that. I think it was already answered during the class. What percentage of information does model consumes from context when answering queries? It really depends on how big the context is and how big the query is. So if I have 10,000 tokens and the query is 1,000 tokens, then it consumes 10%. That's how it works, right? I'm having trouble bridging the gap between a custom model trained on data versus a foundation model, LLM model. If I need something precise, like giving an input, I need a numerical value, how would an LLM help me with that? It probably wouldn't. It depends on the use case. My experience with generative models is that they are chatty. Yes, you're absolutely right. So a foundation model, that's a new term that we came up to name these specific LLMs provided by, there are general LLMs, all-purpose models. Those are foundation models. That's the term that we're using, okay? So Gemini, Grok, GPT models, Llama, Qwen, DeepSeek, those are foundation models, okay? Then we have specific custom models that you build to solve specific problems. Specific problems require specific solutions. General models, not great usually at specific problems. If I want to predict how many times my wife wakes up during the night, I need a custom model. An LLM is not going to do that. It's not going to be great at that, okay? So usually in those cases, you build specific models to solve that problem, okay? I built a model to detect whether insulators are broken. An LLM is not great at that. It sees images. It doesn't know the conditions necessary to understand whether an insulator or a transformer or an arrestor, those are electrical components, are broken or not, because it's not obvious why they are. So the LLM won't be good at that. I had to build a computer vision model to do that. Okay, so hopefully that answers the question, Kevin. If not, let me know. Okay, Ahmed, what's up? While you figure that out, let me go to another Q&A.
Yes,
Okay,
sorry.
go. Okay.
Yeah, it's a basic question, okay? Because I'm trying to build a model, just like and deploy it into like Flask or Streamlit, okay? It's just like a regression model. But I want to ask if it's in the life cycle, for example, we want to deploy it with the customer or with the doctor just to predict the disease of this patient, for example. So after deployment, they will keep feeding the system, okay, with the results, and the system should predict the disease. So I don't know if we can add to the life cycle, just like the system should learn also from these inputs and use it also for the training and for the evaluation, everything. But this should be involved. I should always take the data, the new data, and do the training and the validation and everything. All this could be done automatically also. It's like from the new data. Yeah.
Great question. So session 5 is going to end, and session 6 is going to begin with the idea of continual learning. So how do we get a system that can, after you deploy it in production, starts learning from new data and keeps updating itself? We're going to cover that session 5. That session 6 begins with that. Okay.
Okay. Thank you.
Right. So general question. I read some articles where researchers fess up that they don't fully understand how LLM's models function internally to explain some of the results' behavior. So basically, is this a risk? Is this a problem? Yeah, the reality is that we do not fully understand how these models work. So we have a very good idea at a high level, but as soon as you start getting into specifics, why am I getting this answer versus these other answers? We do not know. These models are just too big, and it's very, very hard to understand. Like, your brain does not understand more than 3 dimensions. You see in 3D, you do not understand how things relate in 4 dimensions. It's very hard. Imagine now in thousands of dimensions, which is how we're representing this data. Very, very hard for us to think that way, right? So we do not understand how these things are actually working. So it's very hard for us to fix individual issues and fix specific issues. Is this a risk? Yes, it is. You're seeing it right now. These models still hallucinate. We don't know how to fix that. If we understood how these models worked 100%, we would have fixed hallucinations by now. That would not be a problem, right? We would have fixed that by now. But we just don't know, unfortunately. Okay, let me keep going. Is model versioning only applicable for model-centric approach? What if we change the data set during development as well as model? So no, model version, remember, every time you change the data set and you retrain the model, even though you're not modifying the parameters of the model, you are obtaining a new model. You also need to do model version. So part of your pipeline, regardless of how you're going to modify your data or your model, part of your pipeline should be version. In the code walkthrough, you are going to see me versioning my models using MLflow. This is something that's very easy to set up and forget. You set it up, you forget, and now you get the benefit of it. Okay, so regardless how you modify your data or your model, you version every new model that you generate, you version. I'm assuming you must anonymize all traces logs. Are there any useful tools for this? There are tools. I do not know off the top of my head the tools, but if you're running data with with prompts and input data that uses personable identifiable information, you must anonymize it so you can store it, because if not, that data will leak, and that was going to be bad for you. So you must do that. I know there are tools that anonymized data, obviously. You just need to find one and use. I don't know the name of the tool off the top of my head, but there are tools that do that, yes. Model version is their recommended template for a metadata to collect for a model. Name, date, created, versions of tracing data, etc. So yes, so when you use a tool for model versioning, these tools usually are going to collect a lot of data automatically. So you don't even need to worry about that. You don't have to think about, oh, I'm going to version this and that and that. You just say, I want log this model, and the tool will automatically track a lot of information. Automatically. We'll grab the weights, the data that generated it. It's just a ton of stuff. If you go to the code walkthrough and you go to the registration of the model that I do, you will see how I'm logging the data, and you can check in MLflow all of the information that gets logged. And you will see that MLflow is automatically tracking a lot of the data. If you use weights and biases or Comet, those are two commercial tools, same thing. They do a lot of that. You don't have to worry about it. So you just use the tool will log everything for you. Okay, let me keep going. Are Hugging Face models, transformers considered foundational models? Not every transformer is considered a foundation model. Usually foundation models are the llamas of the world, the GPTs, the Geminis. Those are like the big models that everyone is using. Those are foundation models. Again, tomorrow you're going to read a paper or some scientist is arguing that no, foundation models actually mean, who freaking cares? Like, it doesn't matter. Semantics. Researchers love to talk about semantics. In an academic environment, once you test your model against the test data set and happy with the accuracy, that's the end of the process. That's usually the way it works, yes, in academic environments. In short, could you speak about the next steps, such as integrating the model into a complete solution? Well, here's the thing. Researchers have a very different goal than engineers working in a commercial environment. Researchers, usually their goal is to prove that one algorithm works better, right? So they might use a fixed data set that the whole industry agrees on. Oh, this is a good data set for images. For example, the ImageNet data set is a famous one. And any researcher wanting to build a good classification model will use that ImageNet data set as a benchmark to compare different versions of the model. But that specific architecture might be very good at ImageNet, but might not translate well to a specific problem in the industry. So researchers are fine by finishing there. They have nothing else to do. But you as an engineer, you need to understand that because a model is state-of-the-art in ImageNet, that does not mean it's going to be the best solution for your particular problem. You need to understand that there is a difference there, because benchmark is incentivizing the model to do one thing. The real world is different incentives. So I'm not sure whether researchers have anything else to do. I'm just saying that you as an engineer, your job is completely different. So just doing well in the test data set is not enough. You have to go and deploy it and test it and monitor it over time, et cetera, et cetera. How do we pick the model to fine tune? For example, the model that we should start training on. Usually the way it works is you find a model that works relatively well for your problem, and then you improve it. So for example, if I wanted to fine tune a model to write like me, I will start with the model that I like the most, that writes, that I can control the best way, or that it produces the best content. That's what I will look at. So maybe that's Gemini 2.5. And now I want to take advantage of that capability and fine tune it so it's even better. So usually you start with a model and then you fine tune it to do something better. If sometimes you do it based on requirements, like, well, I'm going to be running my model on a small device, so I cannot fine tune GPT 3.5. I need to fine tune a smaller model so it can fit the memory requirements of my device. And that's what you would do. Okay, all right. Let me see. I'm going up through the questions. I'm getting to the beginning of the session. Where can I find a good buzzword explanation for LLM algorithms that I can follow your slide faster and do not have to ask too much stuff and slow you down? I'm trying to stay. I don't know where to point you. I'm trying to stay as far away from theory as possible, meaning I don't want to tell you, learn what a transformer is, because that will be too deep in the weeds. I don't know if anyone has any idea of good tutorials or good places for somebody to get a cursory knowledge of this stuff. Please recommend them in the chat. I'm not sure where to point you. Let me see. Eduardo, I have a doubt. Let's say you apply standard normalized to train the model and/or PCA. The model learns all of these transformations, of course. My question is, do I need to use the same transformation performed during training process or need to be done from scratch in production over the data sets or something? Okay. Let's see if I understood this correctly. However you transform the training data to train your model, whatever you do there, you have to do in production. The shape of the data in production that goes into the model to obtain an answer has to be exactly the same than the shape of the data that you created during training. If you reduce something using PCA during training, you have to reduce it during production. If not, you're teaching the model with a shape and then asking questions about a different shape, okay? So whatever you do during training, you have to reproduce during inference, okay? Very, very important. Keep going. On which test data set should you perform the final evaluation of the model? Would you carve out a separate holdout set from the initial data set? Yeah, that's what the test data will look like. You get the whole data set and you split it. You take the big training portion, that's for training the model. Then you get the rest, you set two data sets apart. So one, you put in a drawer, you never look at it. That's your final test evaluation. That's the one you're asking for. The other one is the one that you're going to use to improve your model. That's the validation one or the development one. People call it development or validation, doesn't matter. But the test data, that one is the one that you're going to use for the final evaluation of the model. Talking about cross-validation, does that mean that you're using the whole data set for the training and the testing and not a portion of the data? Well, yes, but you're doing that overall, yes. So what you're doing is you take your whole data and you get a portion of it, and that portion you test, and then you train on the other portion. And that generates one model. Now, the second model, you do the same thing, but the portion of test is different, okay? And you train a second model. So those are separate models. So if I'm doing 5-fold, I'm creating 5 separate models and evaluating all of them individually and then combining the results in a single metric. So the first model might be 80%, the second model might be 100%, the third model might be 90%. So I'm gonna sum them up, 270 divided by 3, so the average is gonna be 90%. But
then you need another test set for the assembly, yeah?
No, you don't need a test set for the assembly. You can just do it like this, and that's it. Okay. That average is going to be very close to the actual average of how that model performs. So that's going to. In the picture, the blue square in the fold is actually validation fold. That would be like the final test. So it doesn't need to be a validation. It's just the test. That's how you're going to compute how good your model is and what you're going to use to combine at the end of the cross-validation fold. If we do not apply data transformation, at least some, before splitting, we might not properly satisfy the data in some cases, don't we? Mark, do you mind elaborating on that one?
Yeah. Let's say we do some steps what you told in session 1 to fix like missing values to introduce new columns where we do elaborate analysis of the data and so on. That's pre-processing steps. There are data transformations may be involved, like a PCA. And then we might have found clusters that we want to represent different densities of probability, and then we stratify them to don't get in a problem where we overfit to certain classes or certain densities in our feature space. If we don't do this transformation before splitting, we might end up with splits with unhelpful representations.
Why would that be the case?
Let's say that in one split we have mainly a cluster. Let's say there are two clusters or three clusters in the data, and in a split we might by bad luck accumulate one cluster, and another split another cluster.
Yeah, I see what's happening. The thing is that you think that what you should do is apply the transformations to one split.
Not obviously not all, but some, to get
split, and then start from scratch for the second split and compute the transformations. That's not what you do. What you do is, let's keep it simple. Okay, you're gonna do normalization. Normalization is done by you taking one column of numbers, computing the minimum value of that column, computing or finding the minimum value, finding the maximum value, and then you normalize with those two values, the minimum and the maximum. You're gonna grab the minimum of them and the maximum of the train set and use it to transform the test set. You will not recompute the minimum and the maximum on the test set. You wouldn't do that. Does that make sense?
Yeah, and for a multi-fault situation, I would do the normalization before split.
You will never normalize before split. You don't want to do that, because if you do that, let's say the minimum value is in the test set. Okay? You don't split, but you use to normalize to modify all of the columns. You're using a value that you're not supposed to be aware of, because that value belongs to the test set. You're not supposed to be aware of the test set.
Yeah, got that for the test set. I'm asking for the splits of validation versus the multi-fault split.
Same
thing? Okay.
Same. You're not supposed to be aware of that. Therefore, the way you do it is you take all of your data and you split it first. Splitting, what means is I don't want to show my model anything about the data that I'm going to use to or validate the training. Nothing. I don't want to show it to my model.
You
split it. You apply transformations to the train set, and you use the same parameters that you learned during that transformation and apply them separately to the validation set and to the test set. So that means the minimum and maximum values that you learned during the transformation of the training set, those are the values that you're going to use for the test set. It doesn't matter that the test set has a minimum value. You're not going to use that value.
So on this 5-fold operation, I would get 5 different minimum and maximums and scales.
So the way it will work is, you take the whole data and you will split it first, and then you will compute the minimum and maximum of the and apply it to the test set. And then you will do the same thing for the next time you go through this, you will do the same thing. And the next time you go through this, you will do the same thing. Yes.
You made a very strong case with, I shouldn't know that the minimum if it ends up in the test set. That was eye-opening for me. It's very clear. Thank you.
So some people tell me, this is obviously what comes to mind. Some people tell me, what if there is a category, let's say you were doing one-hot encoding, or you're doing label encoding, where you need to create a mapping and turn text into numbers, right? So we're working with animals, and we split our data set, and we look at the train set, and we have 3 animals in the train set: dog and cat and horse. And we assign a label. Dog is going to be 1, cat is going to be 2, horse is going to be 3. And when we go to the test set, there is chicken. Like, what category do we assign if we have chicken in the test set? And that's a very strong case for no. Let's do the mapping before splitting so we can actually account for chicken. And then I always ask them, so what happens when you deploy the model, you find elephant in production? How do you prevent that from happening? You cannot prevent that from happening. So the solution is not to put together the test and the train set and do this fiddling. The solution is to prepare your model to
have an unknown class.
To see an unknown class. So you have to code that. So yes, if your test set has chicken, tough luck. You're not going to be able to predict those, because that is what's going to happen in production. But anytime you do something with the test set together with the train set, you're leaking. That's what data leakage is. You're leaking data from the future into the present. Make sense?
Makes totally sense.
Okay.
Yeah, I have to, your example also with, I have to prepare for reality, and reality might be unpleasant anyways. So if I have a classificator, I need to have at least something that says unknown class. So if there is chicken, then my model has not totally failed.
Yeah,
that's a very strong point also. Thank you.
So Mare says, once we have the best model and hyperparameters based on validation performance, do we then combine train and validation to train once more based on the best model we got, and then use unseen test data for final evaluation? Yes, and I'm going to go one step further. You can also combine train and validation, test, and that's your final performance, and then combine everything with test and train the model, and don't evaluate it again. Okay? Very common. Where you take, after you evaluate, you mix the data and you retrain again with all of the data. Okay? Very common to do that. So yeah, you should do it, definitely.
But then we have at the end no measure how good we are, right?
You cannot measure how good the new model is. You are going to assume the good model is going to be equal or better than the one that you measured before.
So we hope that we are not totally messing up with some strange effects. Okay. Which is normally not the case. I get that.
Normally not the case, yeah. Are there situations to keep multiple batches of test data, which makes the percentage of the test data bigger? Or is it also better use more data for learning? So what you're going to find that works the best is to rotate the test data. What I mean by rotating is, as time goes on, you're going to keep grabbing new test data and sort of like moving old test data into training. We're going to talk about that in session 3. That's back testing. That's what it's called. Comes from time series analysis. That's a way for you to keep test data fresh. You don't need more of it. What you need is different of it, if that makes sense. You want the test data to always represent production data. As the world changes,
so
you need
this is during after deployment. And I was a little bit about, but I think you answered it with the question before implicitly. I was about, okay, you might do multiple strange things with validation and a little bit of assembly and combination and so on. Do you want to have in your process multiple steps where you deploy test data? But you answered that it's common to incorporate at the end the test data anyway, so that answers this question also.
Yeah.
Thank you.
Cool. How does the validation data improve the model? Is it a different process than training? So the validation data is what tells you how good the model is. Okay, so you train, the validation data does not improve the model directly. It improves it indirectly based on the feedback that you get. Like, for example, I train my model and it's 80% accurate. I test it on the validation data and get that it's 80%. And I'm going to look at what samples it failed and why. And I'm going to go back and improve the model and retest it again. That's the way the validation data improves the model, is indirectly through feedback. It gives me feedback so I can apply it to better model and therefore iterate on it. That's how the validation data affects the model. You don't show that data to the model, like you don't train on the validation data. You use it to gather feedback. Should we prefer models that are explainable, SAP, LIME, over better performing models, or will it depend on the use case? It depends on the use case. For example, if you're working for the government and you want to create a model that is going to determine if somebody should go to jail or not, it better is explainable. You don't want to tell somebody, yeah, you are going to jail because a model said so, but we don't know why, right? So those models have to be explainable. For many other use cases, you do not care about explainability. In fact, LLMs are not explainable. You have no idea how they're coming up with the answers that they did. It's just the case, right? It's very tough to tell somebody the model says so. The model made that prediction. So certain use cases require white box models, and that is one of in the table that I gave you with 8 criteria to select your model. One of them is explainability. Like, is this model a white box model or a black box model? And can I use that for my specific use case? Yeah. When data is limited, is it acceptable to skip a separate validation or test set and rely only on cross-validation within the training set for model selection and evaluation? So this is a great question because I want to generalize it. When data is limited, it's never acceptable to skip on process. When you skip on process, you're making a worse model. So if that's what you have to do, awesome, do it, but understand that you're making a worse model, okay? So when data is limited, work with what you have to. You cannot just make up data, but understand that there is a trade-off there, okay? So yes, you can just say, I'm just gonna use cross-validation here because that's what usually everyone does, just use cross-validation, and that's it, and you might be perfectly fine. But the goal should be to build a better model, not necessarily to, oh, is this okay to just skip this part of the process? Or, well, yeah, there's a trade-off for every decision that you make. We're almost through. One more question here. When you want to split work between sub-teams along the pipeline, good pre-processing, data center AI, right model type, how feasible is this? Is there much coupling between pipeline steps? So usually what I found in my experience that there is better that if somebody just builds the whole pipeline, and then there are going to be specialties in specific things. Like, for example, the data science team, that I'm calling it the data science team, there might be a few people who build the model, like train the model and find the best hyperparameters for that model. They're going to be better off dedicating themselves at finding those hyperparameters for the model and evaluating that model. So they're going to be taking care of that. But there's going to be somebody else that's going to take care of deploying the model, because that requires a very different set of skills. Requires understanding the cloud platform where you're going to be deploying the model, building an API, a wrapper API around that model, etc. So that is how I will tend to split things, not necessarily one team per step, but more logical units. Like, well, the people who
can be persons, if not teams. I'm thinking about. I'm always thinking about parallelizing complexity cross effects.
Correct.
That's always sticking in my mind. Mindset.
Yeah.
So, and the thing is, can I assign people working independently from each other with the pre-processing and with optimizing the algorithm in your experience? Or is the pre-processing very strongly coupled to the chosen model and tuning the model?
So the pre-processing is going to be very tight coupled with training a model. You cannot train a model without pre-processing the data. Now, what could happen is that a team will have like a notebook to do some pre-processing for a portion of the data set, and they will take care of doing that for training their model and whatnot. But a different team or a different person will take care of doing that at scale, which is not about just having a notebook and just pre-processing.
Handling data is not easy.
You have to handle millions of rows. So the other team, using the principles that the data science team is coming up with, it will take care of doing that at scale. So that would be simple.
So you would put all the design decisions in more or less one hand for the whole pipeline regarding the data, and use the scaling or deploying, application, transformation into production potentially to other people with that as a specification.
Yeah, that's a way of looking at it. Could be like that. So he's making the main decisions about building the model, and another team or different people are taking care of deploying or making those decisions at a large scale, like implementing what that would look like. Yeah, that could be a way of thinking about it.
Actually, that is what we do in our team. We have the growth team, the data science team, or project team, and MLOps team. But the thing is, when the transition from project team to MLOps teams, it's individual, or the development is individual, the transition gets messy. So we come across the way of work that we as MLOps team go from the beginning of the project development, besides the project team, thinking how we're going to scale that system from the beginning. So it's maybe we are walking together from that path.
Yep. That makes sense. Here's a question. How do you manage, this is the last question that I have in the QA, how do you manage the cost of storing copies of data for different versions if you have a very large data set? That's a great question, and it's a question for the company who's paying for that bill. So yeah, there are tools that do not duplicate the data set. They only represent changes, just like GitHub does. GitHub, every time you commit, they do not duplicate your whole code base. There are tools that will help you manage this. If your data set is changing a lot between versions, then the tool will help you. Okay. Another way, this is what I've done, is that I never duplicate the data set. I only represent what's new. So assuming that I have a very fixed data set, but it grows over time, I only add new data to it. So I'm not duplicating. A new version of my data set is literally 2 pointers, beginning date and end date for my data. That represents my data set. Whenever I get new data, I move the pointer and maybe discard some of the old data. I get more data, move the pointers. So my data set is literally 2 dates, beginning and end. And the data is represented only once. Now, that gets more complicated when you are doing stuff to that data. You're cleaning that data. You're doing something over to that data. Now, that might get a little bit more complex, and you're going to have to get into these versioning systems for data set. But it's possible to do. Okay, Anuradha. I think that's the way.
Yeah, yes. Anu, you can call Anu. 2 questions. One is, what is hyperparameter? Second, I think I missed in the slide regarding cross-validation that which of the 5 models are you going to register?
Gotcha. So the first question was, what is a hyperparameter? Was that the question?
Yep.
Okay, so a hyperparameter is any configuration setting that affects the training of a model. It's that simple. We just like to complicate things, and we call them hyperparameters. So for example, when you're training a model, how many iterations you're going to go through? That's a hyperparameter, okay? Or what is the size of the batch of data you're going to grab in order to pass it through the model? That's another hyperparameter. Or what is the learning rate that you're going to use?
Basically configuration.
It's a configuration setting. See how easy that was? Configuration. No. Let's call it hyperparameter, because parameter we called when we train a model, the weights and biases of a model, those are the parameters. So when you hear that Llama 7B, 7 billion parameters, that means that they have 7 billion weights plus biases. So numbers stored that represent their knowledge. Those are the parameters, and the hyperparameters, configuration settings. So to your second question, which model do you register? So the answer is none of them, none of the 5. Okay, so first option is you train a 6th model. Let's say you did 5-fold cross-validation. What I'm going to do is train another model, yet another model, number 6. But that time, I'm going to use the entire data set to train that model. So for the 6th time, I'm not going to be splitting, test, train, none of that. I'm going to grab all of the data, transform it, train a model, and that is the model that I'm going to register.
With the hyperparameters I learned were the best.
In same hyperparameters I learned, yes. So all of that stay the same. The difference here between this 6th model and any of these 5 models, the only difference is that I'm using the entire data set instead of 80% of it, okay? And that is the model that I store. And what is the performance of this model? Well, the average of the cross-validation. So if this process gave me that the model is 90% accurate, that's the reported accuracy of this 6th model, okay? So that's option number 1. Option number 2 is that you deploy all 5 models, not just one of them, but all 5 of them, and use all 5 of them to compute the final answer. So if somebody, let's say these models are going to predict the price of the house, I'm going to get all of the input data and pass it through all 5 models and ask all 5 models to predict the price of the house. And at the end, I'm going to average the 5 prices, and the answer is that average. That's what I'm going to tell. So what I'm uploading to the model register is an ensemble with all 5 models. Now,
What if? Yeah, go on, please.
There are pros and cons to each one of the approaches here. Go ahead. What was your second question?
So what if it's a classification problem then of all the 5 models, if they give different answers, how do you decide which one?
You can do voting. So if that's the case, you can just vote and pick the answer that comes up the most, or the category that's the most frequent. You can also do weighted voting. By weighted voting means that you're going to trust certain models more than other models, depending on what you saw during training. So maybe there is a specific model that's very good at classifying penguins, and another model that's very good at something else. You're going to do weighted voting. Yeah.
Okay.
That's what.
Got it. Perfect. Thank you.
Siri, every time I call your name, my phone goes off because it thinks
it's Serhi. You can stress the last.
It's Serhi. Is that what it is?
Serhi. It's okay. My question about this last thing about 5 models in parallel and ensemble. If we are talking about weights, it's basically also parameters, right? So maybe it makes sense to train another classifier on top of like stacking of models. Is that okay? Or like
you can train a classifier on top of all of these. That would be stacking more than ensemble. So you're stacking another model on top of these 5 models. There are many, many ways to skin this cat. At some point, you're just splitting hairs and you're trying to get like a 0.001 accuracy on top of other things. In Kaggle competitions, for anyone who done Kaggle, stacking, ensemblings, those are the name of the game. You do that every single day because you win competitions by 0.00001%. In engineering, there are other things that take relevance, like your time. Like, what is the easiest thing to do, the fastest thing to do? right? Or what is the less costly thing to do? So if you think about these two scenarios, during inference time, here, option number 2, you have to run every input through 5 models. If you have an auto model on top of all of that, that would be a 6th model. So it's very costly during inference time. If that cost makes sense to get an additional 0.01% accuracy, well, so be it. But usually, if it doesn't, then you will go with something simpler to deploy, like the first one. Now, the first one, however, has the downside that you have to do a 6th training process. So you're training your model 5 times to do cross-validation, and then you have to do it all over again. So again, trade-offs. Every single one of these you have to evaluate. It's
Seems
not
like in most cases it won't give anything, like fractions of a percent, right?
That is correct.
Okay.
Yeah. What else?
So the first one is harder to maintain because the training process, if you have to often retrain the stuff.
It's not necessarily harder to maintain, is adding the training cost on top of anything. So if you have, so let's say you have a problem, a use case where you are going to be using the model only a few times, then the second option might not be an issue because you're not going to be exercising that model a lot. Every time you do, you're going to have to run that input data through the model multiple times, but it doesn't matter. You're going to be training that model constantly, but maybe using it a few times, and the second option is less expensive than the first one. Usually, you train more infrequently than what you exercise. So you're going to train them. It doesn't matter that you're going to spend option 1. You're going to train 1 more time. That's expensive, but then you're going to take advantage of that model multiple times a day. So in that case, option 1 is less expensive. Make sense? Andres?
Makes sense.
Yeah, just to make it more clear, on option 2, you register 5 different models and you get the output for the 5 different models on production, and you ensemble or you merge somehow the 4 different outputs into a single output. It's not merging the 5 models into one and register one. It's
not merging them. No, it's just I'm literally running through all 5 models and somehow ensembling that result. That ensembling means, for example, creating a model on top of the results of those 5 models. So it's a 6th model that you're running just to get the answer. Or it could easily mean just averaging all out.
Yeah.
It really depends on what you want to build. Yeah.
Thank you so much.
Jessica.
Hi.
Hi.
One question related to cross-validation. So when we are doing that, we cannot go back and adjust the hyperparameters because we will cause overfitting because we don't have the test.
Great question. So cross-validation is usually used in what's called a nested cross-validation loop. So basically you do an inner cross-validation to find hyperparameters and an outer one to test your model. Very complicated setup. Usually, I've never done it myself. I've seen it done usually in Kaggle competitions. You're right. So here, what you're doing is you should not go back now and make changes to your model because, again, you're going to be overfitting your model. So one thing that you could do is you have your whole data set. You extract test data, put it aside, and then you do cross-validation with the remaining data. So in that case, this blue fold becomes your validation data, okay? And then you do the whole process. And when you're done and happy with it, you test your final model, this one here, this final model, you test it on the test set that you got. Does that make sense? You might be muted.
Oh, sorry. Yes, thank you.
Yeah. Cool. Anything else?
Yes, Santiago, sorry. You mentioned something about Cohere's playground to play with the
yeah, let me show you.
model.
Yeah, let me show you that really quick. It's it's cool. If you want to check it out, we can go there. Cohere Playground. So Cohere, I don't know if you guys know, but Cohere, they provide, I have to log in here apparently. So Cohere, they provide models, like, you know, like general purpose models as well. So if you go to the Playground, you can select, let me see, the Embed tab. And here you can type sentences, like you can say, I like X for breakfast. And I'm going to type another sentence, which is I drive an Audi. And a third sentence that says bacon is good. So clearly you see which sentences should be related here. And here I'm going to say BMW is a fast car. And let's embed all these 4 sentences. So let me close this, let me run, and let's see what we get. So 2 and 4 are closer, and 1 and 3 are closer. So 1, I like eggs for breakfast, and bacon is good. See how these 2 are closer to each other? Yeah. This is I drive an Audi, and BMW is a fast car. Let's try something else. Let's add omelets are awesome. Let's rerun this and see what happens now. Now it's going to produce something completely different. There we go. So we have 2, I drive an Audi, 4 BMW. Now we have 3 bacon, and 5 and 1 are sort of like closer to each other because they are speaking about X. See what I'm saying? It's like this is, you can use this to understand how embeddings work and how the model is capable of putting similar concepts together and separate concepts far apart.
Yeah, okay, got it. Thank you so much.
Cool. Anything else?
What were the challenges you were telling in both the approaches for cross-validation?
The challenges I was saying about the projects for cross-validation, I forgot. What was that?
We can take it up later. It's okay.
Oh, are you asking me any challenges, or are you asking me that I refer to some specific challenges?
Yeah, you were saying that in both the approaches, there are certain challenges in the first and in the second. I mean.
Oh, okay. So you mean the first option versus the second option?
Yes.
So I think I spoke about that, but really quick. The first option, you need to retrain an additional model. So that is extra time, extra money you're going to have to spend. Okay. So if you're training too frequently, that will be a considerable cost. The second option, however, you do not need to train another model, but you do need to run inference on multiple models instead of one. So if you are running a lot of data through your models, that would be more cost. So you have to evaluate which one is going to be better for you.
Okay.
Cool. Awesome. Anything else? Or should we cut and go for a weekend? Now I have to drive like 5 hours. Cool. All right. So I'm going to stop it here. I'm going to upload, obviously, the recording whenever Google gives it to me, hopefully by tonight. And I'll see you, all of you, on Monday.
Thank you.
Have a great one.
One.
Thank you. Bye.
Thank you for speaking. Bye-bye.